Live, I think. Hi, Jan, how are you doing? Let's see how the stream health is looking. There we go. All good. Alrighty, good evening, everyone. So, where do we begin tonight? There's a new tutorial video out, just in case you guys haven't seen it yet. We are on part 9 of our weapons tutorial. Looking at two-handed holding a sniper weapon. I'm not quite sure what I'm going to do for 10 yet. I'm probably going to spend some time on my object handling tutorials next. I might actually do a live stream about that sometime next week. Just to do some experimentation and to just learn some things to actually use in the next part. I want to start looking at opening doors and opening cupboards and that sort of stuff. So that will be announced later in the week if I find the time, if I am indeed able to reserve another night, because I don't want to use my Friday nights for that. I want to keep my Friday nights for our little space game. So, okie doke. Let's give it a few more minutes, see if some people come in. Before we go into it, because I did spend some time this week doing a few little enhancements. So we're going to have a look at that. I didn't do much more with the AI. I've cleaned up a little bit of things. I've started naming or using class name more. Makes it a lot easier to inherit classes. So that's polished things up a little bit. What else? Most of the time is actually spent in the logic for the missile. So we're going to have a closer look at that in a minute. There we go. What else did I do? I think that's the thing that I mostly worked on. I fixed a few bugs. I found out that I broke the sound of the little locking mechanism, so that should be fine now. Yeah, let's just get into looking. Let's actually just run through the demo for a minute, or the game for a minute, as it is right now, and you guys can see what I changed. All right. So our two enemy fighters are still flying around. So the fighter on the right, is following our path, and the fighter on the left is trying to tag along. Let's go and lock one of these guys. I actually want to go a little bit to the side. I'll lose the lock, but that's okay. Because the thing that I want to do is that once we have a lock, and we fire our missiles, you see the little green dot. And there we go, it hits. We actually need to have an explosion. That's also, I think, something that we might do first tonight, is to make sure that we do that. But the little green dot is the bit that is actually important. Now just overshot the enemy because the enemy is moving too much. But basically what I'm doing is I'm looking at the distance between the missile and the target that it's going to, and looking at the speed that the missile currently has. And the missile calculates how long it expects that it still is going to travel before it will hit the enemy fighter. And it's then looking at the speed of the enemy fighter and sort of projecting where it will be. And that's that little green dot that you see, is a projection of where it thinks that it is going to be. And that's where the missile is aiming for. Now when I'm this close, the missile doesn't have enough time to... There we go. The missile doesn't have enough time to actually turn, and therefore it overshoots the enemy. I think I'm out of missiles, by the way. Let's shoot this guy down. There we go, he's gone too. I think I actually need to turn the target lock off here when we are out of missiles. And we need to start looking at a UI to see how many missiles we've got left. There we go. I hope the sound of the game isn't too annoying. The beep is a little loud, so yeah. Anyway, let's have a look at the code that we wrote for this. Now, one of the things that I do want to do, and I haven't had time for yet, is that I want to put the logic for the missile in a state machine similar to how we have the NPC logic. So instead of that logic being all built into the script, which it currently still is, that is one of the things that I'm thinking about changing. But yeah, looking at what we're doing here, most of the stuff is still the same. Here you can see that I have done a lot of defining classes for all our types, so that everything knows exactly what it's expecting to be, and that helps the auto completion, but it also helps the editor find mistakes that we make as early as possible. So it just prevents runtime issues later on, which is kind of nice. But yeah, the important bit of the logic lies in physics project. One thing that I also did is in the friend or foe. So here you can see that I've defined a class name for that, so that makes it easier to access this. But what I've done is I'm now tracking the current position, the delta position, so the position between the current frame and the previous frame, and the velocity of our well, this is both for ourselves, for our NPCs, so both enemy and friendly NPCs. So I'm tracking those. We were always calculating those in the physics process, but we weren't storing them anywhere. I'm now storing them so that they are available to other scripts to have a look at, instead of having to recalculate it every time. So yeah, when we look at our physics process, we can now see that in the friend or foe, we update our current position to our global origin, which is, you know, maybe a little bit double. That one is quite direct to access. But we then calculate the delta position, we update our last known position, and then we calculate our velocity by looking at how much we've moved and dividing that by the time that has passed, and it gives us a speed. We could probably average this over a couple of frames to get a little bit more accuracy and get some of the fluctuations out, but I'm quite happy about that. And what is important here is that we're getting the actual velocity of how the object has moved, regardless of whether it's actually facing that way. Because obviously in space we are turning, and we might not be moving nicely forward, we might be moving sideways, and that's important because that is what we use to target. So when we look at our missile, we can see that here too, in our missile, we are doing that same calculation. We're getting our new position. We're getting the delta position. How much have we moved since the last physics frame? And then calculating, in this case, how far we've traveled. Oh yeah, that's something that we had before already. This changes the size of our collision shape to make sure that our collision shape spans the entire distance that we're going to travel, just to make the collision detection a little more accurate. Then we apply our impulse to actually move or trigger the move. I'm wondering if that means that we should actually be doing that after that. I'm not quite sure. I don't think it matters much because it evens out. You know, we're not going to be moving much faster from one frame to another. We're going to be speeding up, but it's not going to be heaps of difference. Not enough for this to be effective, especially because I'm not taking any acceleration into account in these calculations anyway. That is another reason why it's not super accurate when it's aiming. But you know, I didn't want to go overboard with the logic. So here we're going to see if we have a target. We are looking at where the position of our transform of our target, so that we can get the position of our target. We are then calculating how far away from the target we are. So we know how far we've traveled, so we can get our speed. Here we're looking at, okay, how far away from the target are we, so that we can calculate how long it will take before we get there. So that is something that we're doing first, is that we're going to calculate as if the enemy ship is standing still. We're going to figure out, okay, how long is it going to be that if our missile keeps traveling, and we're assuming here that it would travel in a straight line, which is not true, but it's all approximation that we're doing here. So we're figuring out our velocity, and if we have a velocity, we're going to figure out how long it will take at our current speed to get to our target, and then we're using that to look at the position of our target, and we're adding the current speed of our target multiplied by the direction of movement of our target. So this is how far the target at its current direction and current velocity will travel in 1 second. And we're multiplying that by how long it will take us to travel. So if we take 10 seconds to get from where we are to our target, we're then going to calculate where we expect the target to be in 10 seconds time. Now again, we're probably going to take more than 10 seconds to get to this new location. So it is an approximation, or it might be less. It depends a bit on whether the target is moving towards the missile or moving away from the missile. But it gives a better approximation of where the missile needs to aim, which means that it's more likely to actually hit our target. What we do have is that if the enemy is moving quite fast, and in this case, or is turning quite fast, in this case that is happening because our current AI logic, when our enemy gets hit, he gets knocked off course. He's then trying to get back onto the trajectory that it's supposed to be traveling, and it oscillates and it moves forwards and backwards quite a lot. And what we see as a result is that the target position that we're calculating is moving quite a bit of distance. So we're continuously adjusting the trajectory of our missile to try and hit that target that is moving very rapidly. And there, the missile does get quite imprecise. So I'm still looking at, okay, what can I improve further in this logic to deal with that. So here we see the next step is simply updating our little debug globe. So that's a little green globe that we saw moving around just to help us see what's happening. And then we do the logic that we wrote last week, where it is looking at the angle between the current heading of the missile and the target that it's moving to, and trying to steer towards that target. Oh, I made that mistake a couple of weeks ago. I am so sorry, guys. So I am rambling away here for the last 15 minutes, and you guys have no idea what I'm talking about. All right, so I'm going to do a quick recap. I really have to be more careful. I think I'm not going to use that full screen thing anymore because I keep going wrong with that. So let's restart. Let's reset and play through it one more time. So here we go. So again, like I was saying in the beginning, we've got our two ships that are currently flying. The ship on the right following a set path. The ship on the left. Oops. All right. Trying to follow our wing leader. So and there's that little green dot that I was talking about. That is, there we go. Now we hit him. Where the missile is trying to aim for, and that green dot is being adjusted based on where our enemy ship is traveling, and our missiles are trying to follow that. Now, like that last missile, the ship was really adjusting its course to get back to its wing leader, and as a result, the missile overshot. Now, it no longer has a shield as well, so it is harder for the missile to hit. There you go. And he's gone. And the annoying beeping sound is gone too. I'll just take this guy out normally. Actually, let's see. Too late. It got target lock way too late. There we go. And we take him out. Alrighty. Again, sorry about that. I need to remember to turn the right screen on. So, there we go. All right, get new. Okay. Alrighty. Thank you, Patrick. Yes. Monday was my birthday. Mary Amber, thank you. Barara, Holy feature, watching this live from other side of the world on trains Wi-Fi with no issue. That is quite incredible. I'm surprised the latency isn't killing the stream, but glad to hear it. No, I saw the happy birthday, Patrick. It's just my delay because I had my headset on. I didn't see it until now, and then there's another half a minute delay before you guys hear what I say. So yeah. So yeah, thank you. Monday, was Monday? Tuesday, the 10th. I always forget. The time flies way too quickly. But yeah, it was my birthday earlier in the week. So I took a night off from working on tutorials and stuff like that, and didn't release my tutorial until Wednesday, I think. Yeah, Wednesday. So yeah, I hope you guys enjoyed the tutorial. So let me know what you guys thought about it. So yeah, just to recap, just really quickly, now that you guys can actually see what I'm talking about, which is kind of important. So in our friend or foe, we are now showing or setting a class name. That just makes it easier to use this, so that we don't have to get the whole path to the script in our extends. We can simply, in this guy, say extends friend or foe, and then again we have a class name there. But it also means that we can use that as a classification for our variable types, and that helps our compiler find problems for us when we potentially send the wrong objects to logic, so that it won't work because it's expecting certain methods and properties there. Then the other thing that I did, that I was talking about, is that I'm now always storing the current position, the change in position since the last frame, or physics frame, very important difference, last physics frame, and the current velocity by taking the distance traveled and dividing that by the time passed, so that we have some basic information, because we need this so often to recalculate it every time that we need it. It's just a waste. So just having that calculated once and just ready for us to use makes a lot of sense. Yeah, YouTube chat is really, really weird. That is definitely so. But what do you do about it, right? I have been wondering if I should switch to Twitch. I haven't made the move yet. I don't know. I kind of like the simplicity of YouTube, but at the same time, there are some weird things that you miss and that don't seem to work really well. But as long as you guys can see what I'm doing, and I've got the right screen set in OBS, then it's all good. All right. So back to our changes in our missile process. And again, I do want to change this to working with a state machine, the same as we. Don't go bleep bleep. Can I turn that thing off? Let me just turn that thing off. Don't want to see those. So I don't want to change this into a state machine, the same as we do with our enemy AI. But for now, it's just all in physics process here, where we are looking at how far our missile has traveled since the last frame. We're updating our collision shape here. We're then applying an impulse to change to basically simulate the engine of our missile. And then we're checking that if we have target lock, we are getting some information of our target. So we want to know what its transform is, because we get some different properties from there, and it's easier to just store it instead of accessing it over and over and over again. We then take our origin to get our location of our enemy, of our target, because eventually these missiles will also be used to be fired at us. It's then calculating how far our missile is, or how far away our missile is from the target, so that we can then start looking at how long we would travel to reach that target if the target would be standing still and we will be traveling in a straight line at a constant speed, which we aren't. The target is moving, we are moving, so it's all an approximation. It's not accurate, which is one of the reasons why the missiles overshoot. But I think, it's to kind of keep it simple at this point in time to just try and get the logic as good as possible. I think is enough for what we want to do. So we calculate our velocity first, and if we have a velocity, we're going to figure out how far away from the target we are, and then we're going to adjust the target's position based on the target's velocity, the direction of travel, and then how much time we would take to get to the target. So if we take 10 seconds to get to the target, we're calculating where the enemy target would be in 10 seconds. Now that new location, we might take longer to get there. So again, it's an approximation of where we're going. And of course, the closer we get to the target, the more accurate that approximation is. And it's that target position that then goes into the logic that we already wrote to steer our missile towards that target. So that was the main thing that I did during the week, that I changed away from what it was before. So I think one of the things that probably is nice to do first is to actually have the missile explode when it hits something. Because right now we have the explosion when our enemy gets destroyed, but we don't see anything when our missile hits something. So I think that would actually be a nice thing to do. So there we're just updating our process lock. That's for the engine lifetime. So we actually need to take then the max for the engine lifetime and our explosion. I'm just having a look at if we have a difference between where are we doing this? Where are we detecting? So this is just Q3. If we time out, actually that's interesting because we do on our free timer. That is there. So we've got our, I'm just trying to figure out which way around I've done things. It was a little while ago since I built this. So I've got my lifetime timer. That's right, because we got our projectiles script. That is what I am seeing wrong. So, and again, I think we need to do the same thing here, where we're going to add a class name projectile, which now means that we should be able to go into our missile and simply say extends projectile. Now the other thing which is really cool, when you do that, is that our object actually gets into our node scene as well. So the same happen. Oh, that was not the button I wanted to press. Go away. I didn't actually want to add you. I just wanted to show that. So when we go to friend or foe, you can see that even our friend or foe is going to be in our node list. So we can actually add those right away. And that's really cool with our AI, because right now when we look at our ship, so when we look at our enemy ship or our bomber ship. Oh yeah, that was the other thing. Someone told me how to do an array here. So our default states is now an array, and we can actually stack our default states to begin with. But the thing that I want to show here is, for instance, our AI follow path. Instead of creating a node and then adding a thingy there, we can simply now find them directly in here, and we can add them in. Obviously, I haven't changed those yet, so that's actually a good one to do as well. Let's just quickly fix that all up. So that's going to extend that one. So that I did do. This is follow path. And same for our wingman script. And that should mean that when we want to set up our AI, we actually see all our AI types in here, and we can just add them directly into our scene instead of having to do that all manually. Hi, Wibby, how you going? Alrighty, so yeah, I'm a big fan of the new class name function that they added. I think that was added in 3.1, if I'm not mistaken. But it does allow you to structure things a lot more and find things much more easily. So yeah. Anyway, let's save all these things, even though we didn't change things in those classes. So our lifetime is calling on lifetime timeout, and it is doing that on our projectile. All right. So, and on there, we simply calling die. And when we call die, we queue free. But we've overridden that in our missile, where it then, what do you call it? Lost it now. Where we then do our whole destruction. Now, the question is, yeah, exactly, over here. So when we hit something, we're obviously telling the thing that we hit that we gave it damage, and then we die again. So I think the thing that I'm going to change here is going to be interesting to see if it finds all the places that we need to fix up. But I think the thing that we're going to do here is we're actually going to tell the die function whether we died on timeout or that we died because we hit something. So that when we hit something, we can actually do our explosion if applicable. So. Okay. I just got a text here from Wibby. So now I know who Wibby is. Hey, really cool that you joined my stream, my friend. Feel free if you want to say a little bit more about who you are in chat and what we talked about. So I'll leave that up to you whether you want to divulge that or whether you much rather just lurk behind the scenes. Anyway, no. So we're going to give it a variable where we say, well, we timed out or we hit something. So here, obviously, we timed out, and here we did not. And again, this is where it really comes in handy to have those checks in there, because it's going to tell us when we're missing stuff. So obviously that means that we need to also improve our die function here, else it's not going to recognize that that's the same die function. But we can now use that to do an explosion if we hit something. So if we didn't time out. And that will also change our lifetime there. Now I'm going to quickly have a look at the other projectiles that we have. I don't think any of those have a die function. That's our weapon. So we just have our laser beam and we have our missiles. So that's all good. We don't have to worry about it. I do want to add the die function into the laser beam because for the laser beam I also want to have a tiny little particle effect so that we can see where it hits something and react to that. Okie doke. Cool. I need some drink. I am running out of water. All right. So let's not worry about our laser beam just yet. Actually, let's close everything and just open what we need because it's getting a little bit busy. Alrighty. So what we're going to do is we're going to actually make that a variable, because obviously if we did not time out, that means we hit something. We're going to do something that makes this thing explode. Alright. So, in order for this thing to explode, we need a particle system. Now, we already have a particle system for our nice little engine. And I actually want to go and turn that off for a minute, because that is really annoying. That probably means that we need to make sure that we turn that on before we forget to do that. We don't have an onReady function yet, so let's add a ready function in here. And what we're going to do here is turn emitting to true. So that way we don't get that whole white blob in here, because we don't really want to see that. It just gets in the way. It just starts emitting our engine when we actually fire. Alrighty. So let's go and add in another CPU particle system. Now it's getting a little tiresome that I keep using the same object for the explosions, but I might add a bunch of new particle images in there so that we can do a little bit more. But this one is going to be a little bit different. So we're going to turn that into a one-shot, but I'm going to leave that off just for now. Let's first make sure that we actually see something coming out of this thing. So we're going to start with a quad. There we go. What's it doing? I was expecting to see at least something already. No? Oh, because this one is not emitting. There we go. I was wondering why we weren't getting any particles. All right, so here we have our particle mesh. We're going to add a spatial material to that guy. We're simply going to make this guy transparent. We're going to make this guy, we want to use as a albedo because we want to change our colors. We want to make sure that we have a particle billboard. We do want to keep our scale. There we go. And now we need to start making sure that this thing actually looks like it's throwing everything out. Now, the other thing that we're going to do is we're actually going to make this an explosion. Oh, that's not in here. So we're going to go back here. Oh, yeah, that's something that I forgot. I need to put my texture in. Go away. So, assets. Is it on MISC? Yep. Our little radial texture. So we're just going to do that. And that reminds me, we also want to do that as an additive. There we go. So we got a bunch of particles falling down. Now we need to turn that into an explosion. So the first thing that we're going to do is we're going to increase the explosiveness. Boom. Now what this does is instead of the particles being emitted all in roughly, fixed intervals so that we get a constant stream of particles, this basically means if I put this all the way at 1, it's launching all the particles all at once. While if this is at 0, then we get a steady stream. So I want that to be pretty high because we're actually going to make this one shot, which means that just happens one time and then it ends. But I'm leaving one shot off right now, so we constantly see our explosion effect until we get it to a point that it looks like the way that we want it to look. All right. So with that, that was not what I had in mind. I did want to increase it, but not that crazily. So the first thing that we're going to do is we're going to turn gravity off. There is no gravity in space. But that now means that all our particles are being emitted at the same spot and they are not getting any velocity, so they're all staying at that same spot. So obviously that's not something we want. Actually, one thing that I quickly want to see is did I by any chance get the particle from Godot? No, I didn't. Okay. Godot has got a nicer particle for this sort of thing. So I might actually quickly see if I have that somewhere because no, it's not over there. I need to go into development. Where would I have used that before? Where would I have used that before? On any of these? Probably in some of my tutorials. Oh, of course, I use that in here. So, Godot. Nope. Where did I put you? Did we just put that in our effects somewhere? Here we go, smoke particle. We're actually going to go and use that one. And we're just going to put it in here. So that's one. That's a little particle that comes from one of the fire demos that is on the Godot website. So we're going to go and use that one. And the reason why I want to use that one is that this looks a little more like an actual smoke thing. So once we start making this work properly, we're going to actually have a much nicer effect than we currently have. So what we're now going to do is we're going to give these things an initial velocity. So let's give them an initial velocity of 10. And the other thing that I want to do is I want to put this on the maximum amount. So what we're now getting is that we're getting every particle emitted in a random direction all the way around our emitter. So we're basically getting a nice little puff that starts and they are moving outwards. All right. I want a little bit of randomness in there so that they all start at different speeds. That's all good. And we might put some acceleration in there. I'm not quite sure if that's a smart idea. We shall see. All right. I'm wondering. I don't know if it's fast enough because, of course, we're seeing this from quite some way away. So it's easy to get this to be way too slow. So let's go and up that a little bit more. I just want them to move far away enough because we're going to start playing around with sizes. Oh, something's pausing. Let's hope it didn't crash. No. It might be too much. Let's start it over here and just see what we get, because we are now going to go and put a bit of scaling in there. So let's start with adding a new curve here. So we are going to go. We're going to start at 1, and we're going to, let's say that we end at 10. And then we're going to add a point over here. And we're going to add a point over here. And we're going to go and move that up. So the idea here is that our particle starts small and then gets bigger over time. All right. So now we need to do something fun with the color. So we're going to add a new gradient in here. And we're going to make this thing start, maybe something with like a yellow. We actually want to go and end in a black color. There we go. So it actually I want to go all the way black because I want it to disappear, which means we can actually get a bit of a white in there to make it more smoky. And here we might just go towards red. Is that a nice idea? I don't know. Let's tone this down a little bit. Might have made it a bit too big. I'm wondering if we should start with. No, it needs to stay. I wonder if we should start with red and then go to a more yellow color. No, I think the other way around was nicer. So this is always a bit of experimentation and seeing what works. And we can be fine-tuning this for a long time. I am just interested in the initial effect. And we will improve it eventually. So one of the things that I'm really thinking about is at some point in time to do a... I hope someone fixes that bug one of these days, that it just sort of remembers that you've got that thing selected and it starts moving all of a sudden. All right. So basically now it's going to become one shot. And that is just going to mean that we get a single explosion. Now this one is 1 second, and we're going to leave it at that. So on our die, now that probably means that we want to go and hide our. Yeah, we do. Never do that. So yeah, I'm thinking about doing a series on particle effects at some point in time, and just having a look at what you can do with the CPU particles and with the normal particles. You start with some simple effects like the engine flame and simple explosions, and then see if we can move up from there and get some nicer things going. All right, yeah, we can try a little bit of gray in there. Let's get this logic in here first. So here we want to. I actually don't want to call that CPU particles. I want to call that explosion. There we go. Forgot to give it a name. So here we're going to set emitting to true. So that's going to kick this off. And the other thing that we want to do is if timer duration is smaller than explosion.lifetime, we're going to do timer duration is explosion.lifetime. So we want to make sure that we don't free our missile class. That's right. Until both our explosion has finished and our engine has finished emitting, whichever takes the longest. So that's why we are adding that in. All right, let's go back to our explosion for a sec and turn that one shot off again. So try a bit more grayish. Yeah, well, that's why I had the gray over here. Could maybe go and make it first go much more brighter at the beginning. No, I don't think we need that one. We could maybe go a little bit more towards this, I guess. Maybe also move that a bit more. It keeps that color a bit longer. We have that glow in there a little longer. And I think I want this to be darker. There we go. Now, I'm not the world's greatest particle emitter designer, so it's one of those things where I really want to read up on what others have done and see if we can take some lessons from that. But I do like that smoke particle. I'm actually going to add that to the explosion that I did for the ship as well. So that's now going to become one shot. And that automatically then turns off. That's good. I want to move him up because I don't want to have that part of that. So if we go to our bomber, I actually also have a death explosion here, which is that one. And that one actually takes a lot longer. You can see that that's and there I want to keep the fireball much closer to the object for much longer, and then sort of fade it out. You don't really see it very well until you take that guy out. So what I want to see is how this changes if we go and where's our material? Here's our material. Oh, why changes may be lost? What are we doing here? That is a subscene. Okay. Look at that. I actually made this to be reusable, so could have reused that for our thing. Anyway, there we go. So that's the vertex color parameters. Oh, there you go. That's what I was looking for. So yeah, I want to use our smoky particles here as well, and let's have a look at. That makes it a little bit less uniform, which is kind of nice. Yeah, I think I like that better. So I'm going to keep that in. Let's unhide our plane. And let's have a look at what happens to our missiles when they hit something. Can't wait until we have an interior for our starting scene. Let's go and get a target lock. Fire our rocket away. Oh, I hit the wrong one. But we did see a little explosion when it hit. Which is really cool. Yeah, that was not bad, actually. And unfortunately, it missed. And it did hit that guy. Okay. And that one missed too. Yeah, that explosion looks nicer too. I still need a target indicator. That's the other thing we still need to build. There we go. Alright. I would call that a successful mission. So while we're doing this stuff as well, anyway, let's take some artistic license and do the same for our laser beam. Now, one of the things that I was wondering about, although I think for our laser beam, and it's actually for our missiles as well, when we hit the shield, I want the shield to actually do something. But that's a subject in its own. I think we're once we're ready to do that, that's going to take us probably an entire night stream to build that. But I think for now, for our laser beam, we want to do the same thing. When the laser beam hits our target, instead of it just disappearing, we want to give it a little particle effect as well, but not a smoke effect, because it's not an explosion, it's hitting. Now, the problem that I have, like I said, is when we are hitting shields, the shield kind of absorbs whatever hits it, especially if it's a laser beam, which shouldn't be doing anything anyway. It should just be, transferring energy. But you're not hitting metal, right? You're hitting a shield. So that's where I'm sort of wondering, should we send a little more information to our die? Like, what are we hitting? It's kind of starts to get a little bit ugly at that point. So that's really one of the things that I don't want to worry too much about right now. Those are things that we probably will improve as we build more of our game. But yeah, we do want to have a an effect here as well. So we're going to go and I'm going to actually go and copy. Actually, we're going to copy this whole thing. That makes me wonder if we shouldn't have some of this in our base class. No, I think this will be different enough from one implementation to the next. So let's just leave that. Well, obviously, we don't have an engine that is emitting, but we do have a free timer that we need to add here. That's just going to be a timer, and we're going to call that free timer. There we go. Is that like this? No, capital T. Let's keep the name the same. And now on here, on our timeouts, that is where we're going to go and call our queue free. There we go. So that takes care of that. Now we just need to have our explosion happen. So we're already hiding that. Actually, that means that in this case, because we don't have an engine, we're always doing our, well, explosion isn't really the right name anymore, but let's just reuse that as a name. And that means that if we are just timing out, then we can just queue free. There's no need to do any sort of animation. It's only if we did not time out, that is a situation where we want to do our little particle effect. So, same thing, CPU particles. Here we go. Okay, now that's the other thing that we do need to improve here. We need to find out better where we're hitting. So our location will be quite off, I think. But let's take it one step at a time. All right. So emitting mount. Let's emit a little bit more. Let's go and make our explosives nice and big again. To make sure this goes and drops out a quad. Let's give that guy a material. But in this case, I am actually going to leave it a quad. Believe it or not. What we're also going to do is we are going to use that one. We are going to make that additive. We are going to make it a particle billboard and keep scale. There we go. And I think the rest we're going to leave the way that it is. The only thing is we're going to make it much, much smaller. Maybe even that. Again, they're, when you really think about it, they're way too big. Like now they're 20 centimeters by 20 centimeters. So we're sort of like getting the effect that we're going to chip off 20 centimeter square pieces of metal. But we're going to make them that big because else we don't see anything. Okay. So we're not going to care about the direction, but we are going to care about the spread. We are again going to take the gravity out because that does not make any sense. All right, I think those things need to be much faster. There we go. We got some thingies flying off of it. I'm wondering if we should do a little bit. This is where I think it would be nice if we had that doesn't seem to have the effect that was. I'm trying to make them sort of twirl, but let's just leave it as is. So we're not going to change the scale here because we're simulating that we're getting parts blown off our ship. But we are going to play around with the color. We're going to, again, make him a color that they kind of start hot. But we want to go and fade them out. Boom. Let's just see what that looks like in game. They're going to be one shot. There we go. Actually, I think I want these to be. Yeah, that's really good. Yep, that's good enough for, I think, the effect that we're going for. Again, I'm expecting them to be hitting in the wrong spot, but we will see. Okay. Oops, I didn't mean to shoot it. Well, we are seeing nice little particles fly off, which is kind of nice. I'm actually not against it. I was expecting there to be more of a visible difference between seeing where we're hitting them. There we go. I don't want the annoying sound. So yeah. It's actually, I'm kind of happy with it. All right, cool. So we have at least some visible indicator of where we're hitting. Now, I think I'm going to actually make them even a bit bigger. Let's actually make them 1.5. And let's just see what that looks like in game. And then we'll discuss a little bit more about what I was worried about and what I was expecting to happen. All right. On the world's worst aim. There we go. So now they are a little bit more visible than they were before, which is kind of nice. So they're obviously much bigger than they should be. However, it makes it more visible, it makes it more clear what we're doing. So the thing that I was worried about is our laser beam. And our explosion is going to be on the center of our laser beam. But what we're doing in our code is, and it's actually, is it in our laser beam code? Yes, it is. We are adjusting our collision shape based on how far or how fast we're traveling. So that the collision shape actually spans the whole distance that we're moving from one physics frame to the next. And obviously, if my ship is here and my bullet is traveling fast enough that that's the size, it's going to hit the ship over here, but my explosion is going to be way over here. It's not going to be where I hit the ship. It's going to be halfway between where it was before and where I'm hitting the ship. So there is some disjoint there. Now I'm wondering if we could potentially move it forward, assuming that when we hit, it doesn't already calculate that our laser beam is bouncing off of things. That is something that I also need to look into and see if we can prevent that. But seeing how close the effect was, and because everything's moving already, you know, especially when the enemy ship is moving away, we're hitting it, we're getting our particle effect. That particle effect will already move away from the ship that it hits as it moves away from where it was hit. I don't think we should worry that much about the effect. We have something that we can see that we're hitting. It has some form of visual indication. I think because of the scale that we're working at and the distance that we generally will be from our enemy ships, I think it's enough of a visual cue that we're actually hitting something. So I'm kind of happy with the effect itself. Now, the particle explosion itself is way too simple. There's probably a lot more that we can do there to pretty that up and make it look nicer. But for now, you know, especially because we're always looking at it from a large distance, I think we're for just something quick and dirty, I'm happy with what it does. Okay. So, you mean the explosion of the ship or the explosion of when we hit the lasers? Because if we're talking about the explosion, then yes, maybe we should move that a little bit quicker. I think it doesn't. It would be good to actually have it be a bit bigger too. So when we're looking at our scale here, let's scale that up to 30. Yeah, and then okay, let's see how that looks on the scale of a bomber. I might have just made it a bit too big. Oh, on the scale of a bomber, it looks okay. I actually wish that we could have the acceleration as a graph. I think that's something that we can do with the GPU particles, but not here. That would actually be nice, that you could actually just have a velocity curve. We have an acceleration curve. No, I want to actually have a velocity curve. That's a shame. I get why they don't do that, because obviously with also the gravity being worked in, that's kind of tough to do. Let's up that a little more and see what happens. There we go. Now we've got the smoke particles really moving away from the ship, which is kind of cool. Yeah, I think I like that more. Let's have a look how that looks in game. That's a bit of a shame because nothing is moving. It's always hard to sort of judge exactly how it works. Now, obviously, I don't have something where we actually see the ship falling apart. Well, I've got my glasses. No, it's sitting all right. There we go. All right. Okay, I was way too close when it finally exploded. So let's move away from this guy again. Maybe hit him with a few missiles. Of course, the first missile hits and sends him, of course. Ooh, that actually hit him. Ah. Oh yeah. That doesn't look too bad. Alright, let's see what we can do with our smaller targets over there. Yeah, I definitely need to have a targeting reticle or something like that. No idea if I'm hitting something from this distance, but... Oh, I am. Pretty good big explosion. Yeah, that's kind of cool. I hope you guys like that one a little bit better. You know, you could really spend a lot of time tweaking these things to look, make them look better and better. This is where an artist hand, I think, comes in great. But yeah, I think that'll do fine. Okie doke. All right. Let's go back to our start scene. So the next thing that I want to do, let's just keep that name path, I think. Can I rename that just for that? Any problem? 01. Yeah, that's good. That's good. All right. Add another path. We'll call that one path 02. Move that over here. Top view. Remains a interface that I'm not too happy with. Okay, now that's the other thing that I always keep doing wrong. 0, 0, 0, 0. Boom. There we go. All right. Let's go and move these guys somewhere else. The reason I just moved that path there is so that the path itself is actually centered on where our bombers are. Now let's go and give these guys a bit of a flight path as well. Close curve. Make that nicely rounded. I think we put too many points in here, but that's okay. Yeah, we definitely put too many points in here. I don't think we need this many. There we go. It doesn't have to be pretty. It's just a placeholder anyway. And obviously this guy, what did we do for humor? 10. I think 10 is even probably too much. Yeah. Just bake every 10 meters waypoint. So these guys are going to follow that track. Those guys are going to follow that. I hope they don't end up colliding. Which is of course very possible. Let's just start moving this a little bit more like that, so it's not all. Don't know if you guys can hear the birds going crazy in the background. There we go. Okay. Okay, I hope those two are still kind of aligned. They probably aren't. Yeah. That will have to do. It's not a pretty curve, but it's something they can follow. All right, so. Okay, now that's, oh yeah, that's right, because its default states are like that. They're all set on this. So this guy is going to follow that path. This guy is going to follow that path as well, but also this guy is going to have this guy as his wing leader. There we go. Cool. Noise. Is there a noise on the... I mean, noise is nice. Just to check something. Oh, I don't hear anything on my end. So let me guys know if the audio quality is good or not. Case maybe. Hopefully it is. Alrighty. Could be that my fan of one of my computers is going a bit strong. Okay, so now those guys should be flying around as well. We might have given them a way too big thing to travel. I don't know. View path. I guess we could move it all a bit closer. Actually, let's go and take that one out because we got way too many points. Let's go remove a few that are just a bit overdone. 20 you, I think. And I can go put him there. There. There you go. So yeah, these guys have a bit bigger patrol path, but that's okay. Okay. Cool. All right. So now we should have all 4 enemy planes flying around in groups of 2. And again, the idea is, this is just some placeholder, placeholder scene. But in a real game, we would, in a real level, we would actually have quite a lot of ships sitting around. And we might, and that's something that we haven't done in this yet, but we might even have a trigger point that they are just going to be sitting around, sitting still, turned completely off, maybe even hidden, until we get close enough, and then they sort of start doing their thing and following the path. But we don't want our enemies to just float and follow a path and ignore what is going around them. We want our enemies to start attacking us when we go into view. Now, at this point in time, I'm going to keep the wingman following the wing leader at all times. So it's the wing leader that's going to attack, and it's going to be the wingman that just follows the wing leader and doesn't actually, doesn't do anything until the wing leader gets destroyed. Then the wingman starts doing something as well. Eventually, we'll give the wingman some logic as well, that they can decide whether they want to attack or not. But they probably will be more conservative and go back flying on the wing leader's wing as soon as that makes sense. So for now, for tonight, we're purely going to start looking at how are we going to enhance our wing leader's logic, that if we come close enough, that he starts attacking us. Now, one problem that we have is that right now on the scale that we are, and it's in part because I don't want to fly large distances until something happens, the bombers, the enemy bombers, are quite close to us already. They're actually at a distance that they should already start attacking us. So we're going to start by building this logic with them only reacting when we come a lot closer than what would normally be what you want. All right. All right. Okay. So let's go to our bomber logic. And again, the important thing to know here is that by default, our follow path AI is going to be active, which is going to follow our path. But for our wingman AI is active. So even if we add stuff to our follow path AI, for our wingman, that's not going to be executed, because right now it's our wingman logic that is being executed. So that's its current state. And what we're going to add to our follow path is we're going to add a radar in. And that radar is going to be able to detect in this case, our friendly guys, so ourselves and our teammates. All right, so same thing actually to do here. Now, in this case, I need to do this. So that's the one that I want. I wonder why I put that in the walls. So this is a thing that I made before, and I'm actually going to make this a much smaller distance. Let's do 500 for now. So basically, this thing is going to start tracking whoever comes close enough to our ship to actually, become a potential target. So, first thing that we want to do is we want to actually be able to set that on our AI itself. So we're going to add another export float here. did I call it here? I call it radar range, so I'm going to keep it calling it radar range here as well. And let's actually default it to that 500. That's fine. We don't have a ready function here, so again, we'll just add a ready in here. Let's go and make that a bit bigger so we can actually see what we're doing. Ready. And what we're going to do here is on our radar, we're going to copy our radar range. So that means that when we start our game, it gets whatever radar range we have set. So on our bomber scene, we now have our radar range as a property on there, so we can give different units a different distance that we're going to be checking. Now the other thing that we want to do, and I'm going to go and copy this over, is we're going to do the same thing for the mask. We obviously want to change which mask that is going to detect. Now, do I want to have that be a set get as well? Yep, we are going to do it like that. Or do we? I'm wondering if there's a situation where we want to make this something that changes. I think we're just going to do it like this, actually. I don't really see a situation where we would make that change. So in this case, we're going to say radar.collision. Why does that not find a collision mask? Okay. I'm not sure why the auto completion wasn't working there. Because we are on the correct scene here. We have the correct thing there. There's collision mask. I don't know. One of the mysteries of Godot, I guess. So we're going to copy our radar range and our collision mask, which now means that in our bomber, the collision mask that we want to set is we want the player and friendly targets to be found by our or detected by our radar. All right. Okay. All right. So we're going to put our radar logic actually at the beginning here. In our radar script, we simply have a get closest function that I already wrote for our own ship, which gets the closest body that's in our area. And what we're going to do here is we're going to detect if we find a friendly ship, or whatever this AI is looking for. If it finds one, it'll select the closest one and it will go and attack that guy. So what we're going to do here is say far closest is radar get. Okay, this is very strange that it's actually not doing my auto completion. I'm wondering if we got something, because it does do the radar range, but it's not finding my my functions. So the parameters here is that we're checking and within angle cos, and this is to make sure, this is like when I'm using this for our missiles, that I just want to look at a small cone ahead of the missile. In this case, we're going to be looking all around. Our enemy is going to realize when there's something sneaking up behind them. Now, we may at some point in time say that some of our enemies, we want to limit that. And the other thing that we're checking here is in group. And that's something we are going to ignore in this case. This is important for our radar in our ship, where we only want to find the closest enemy. even though our radar is also finding our friendly ships. So that's why we want to filter those out. But in the case of this logic, we just want to find, you know, whoever we are looking for. So our AI is only detecting the things that it actually wants to be able to attack. And what we're going to do here is, if we find one, we're going to change the AI to an attack AI. So that's going to be an interesting one. What we're going to do for there is we're going to issue a signal here, and we're going to say found close target. Actually, let's say found target, and we're going to give it a target. So that's a signal that we're going to emit. So over here, we're going to say emit signal, found target, closest. So if we found a target that's close to us, we're going to emit a signal saying, hey, we found someone, and we're going to leave it up to whatever is outside of us to decide what it is that we want to do. Now, the first thing that we need to do is we need to create a new stage list. Now, one of the things that I want to see, because I didn't do that when I created these, is if it is actually enough to say, well, let's create a new script. And we're going to go and put that into our states. And we're going to call that AI attack. Oops. Target. Boom. And that's going to be inherited from AI base state. Boom. There we go. And then obviously the class name here is going to become AI attack target. And we're going to have to implement that. So now what I wonder is, if I do this, boom, then I get that. And that's actually not becoming a subscene. That is just becoming a node linked to that script, which is exactly what we want. So I can actually change these guys over at some point in time as well. I'm not going to do that right now. I'm not going to change too much. That's something that I'll do off camera. But for now, that is what it is that we want to do. So here we now have a found target. All right, that's how it's good set. This means that it's not set up. Now we have a found target script, and we're just simply going to connect that up. Boom. So when we found the new target, then obviously we need to go and communicate that target. Let's actually go and create on our attack target. Let's create a export, and in this case we can therefore say friend or foe var target is null, so we can go and set that target up. And I do actually want to set get here, set target. So we're going to go set target, new target, because we're going to be doing some more there very soon. What I'm going to do here is if target is our new target, so we haven't changed it, then we're going to go out, and then we're going to do if we have a target, then we're going to go and deedit some stuff. Now we're going to say target is new target. And now if we have a new target, we're going to go and init some stuff. And we will implement that all in a minute. Export isn't. Ah, that is because. How do we do that again? See my missile. Actually, seeing that it's never going to be one of those, we can actually just say that's just going to be a target. Var target. We're not going to make it a setter. We do have the set function. We're not going to make it a property. That's what I want to say. We're just going to make that a variable local, and we're going to set that by calling set target. Hey, Game Endeavor. Hope you're doing well. Alrighty. So that means now in our script here, is when our AI found a target to attack, we're now going to say states attack target, set target to target, so that it knows what it's doing. And then we can change our state to our attack state. And again, we're going to stack that. So as long as we're attacking our target, that is going to sit underneath our follow path and take over from our follow path. But if we, for whatever reason, stop attacking our target because we destroy it, or because we lose track of it and it flees away from us, then obviously it's going to be taken off of the stack, and we're going to go back to whatever was above it. Same as, with our wingman, when our wing leader gets destroyed, it goes back to following its own path. All right. Cool. Now the thing that I wanted to do here, and that's something that I wanted to copy from our target here. Did I do that in here? I actually did not do that in here. Okay, interesting. I need to do that in there as well. So where did I do it? I think on our player script, on our instruments, like here. So the things that I wanted to do here is whenever our target gets destroyed, obviously I want to go and disconnect myself from, or I want to clean up the fact that that's my target. All right. So when our target is no longer our target, we're going to disconnect from our died, and if we do get a new target, we are going to connect to that. So that's just going to become target. All right. I think for our missile it doesn't actually matter because we are always checking whether our missile is still our closest enemy. No, it's not. It is actually going on here. Okay, that's something that I am going to fix. Not right now because that's a distraction right now. Actually, the name is target died. But that's something that we need to improve on the missile, because right now, if we destroy our target while our missile is still attacking it, we probably will end up crashing. It's going to be interesting. Haven't run into that situation yet, but we would eventually. So, mental note, I need to fix that. Funk. Target died. So, when our target dies, when our target gets destroyed, that's one of the scenarios where we no longer have a target. So, we want to actually go and exit. And what I think I'm going to do here is I'm actually going to call set target, and I'm going to set that to null. So in this case, what we're going to be doing is any situation where we're going to clear our target, we're always going to clear set target, which means that if we still have a target, we disconnect. Because when this is called, when target died is called, I think that is called right away when it's exploding. So it actually doesn't clean it up right away. So we have a couple of frames before that becomes a problem. No, actually that's in our friend or foe script. So yeah, when our health reaches 0, we do emit signal died. And we're still playing our animation player death. And it's that animation player that eventually will time out after a second or two, and then we actually queue free our enemy. So yeah, I think that'll do fine. I think that will do fine. It's all the sort of things that we need to check eventually and test for. Okie doke. So in this case, so this gives us one place that we always call to clear our target, whether it is because the target died, like in this case, or whether it is because we lose track of the target. We call always the same function. So we always have one place where we can then decide what we do if we no longer have a target. And the thing that we're going to be doing is emitting a signal. And I'm going to have a sneak peek at how we're doing that in our wingman script. Is we're going to emit a change state null to clear our attack target state from our state stack, and that's going to return it back to whatever is on top of that, which in this case would be our follow path. So our enemy should be following our path. When we get close to our enemy, it's going to start trying to fly towards us, and if it loses track of us because we fly too far away, it's going to return back to its path. So that's something that's going to be interesting to see if we can make that happen, or if it's going to be too fast and it's going to actually fly towards us. All right. So, okay. Now the thing that I think I'm going to do is I'm actually going to copy our wingman code, and we're going to start with that. And the reason I'm copying that is because there's a lot of overlap in our logic here. All right. So, all right. Now what we're going to be doing here is basically we're going to fly towards our target because we want to try and shoot our target. It's probably going to be more helpful that if we start doing something more similar to how our missile does things. But we're going to keep flying towards our target. Eventually, when we're close enough, we're going to trigger shooting our target, which we're not going to do right away. But then when we get too close to our target, we need to evade. And we're going to be doing that by creating a new AI, an evade AI, which is then going to turn the ship around and fly away from our target again. Yeah, I think it actually was a mistake to use this. So I'm actually going to take that out. Yeah, I'm going to take it out. We're going to go and write this anew. All right. I think we're going to base it more on our missile logic. Follow path. I do want to go and do all these. I copy them over here. So these are all our properties that define how fast our character flies. Now we will probably up this a little bit. This is the same with like the wingman. The wingman, I've made him actually go faster. I'm actually going to do that here too. There we go. We're not going to worry about look forward. That is something else that was specific to that logic. Okay, we're going to go and copy this. So that's our cutoff angle for our steering. So yeah, I think we're just going to put some logic in here. Let's actually go and look at follow path. We're actually going to go and always thrust. So as long as we're in our attack mode, we're going to thrust forward because we're going to be steering towards our target, and we're just going to go full force and go as fast as we can. Excuse me, as fast as we can to try and attack our target. And when we get too close, we're going to go and decide either to throttle back if our enemy is facing away from us, if it's chasing. And if our enemy is flying towards us, we're going to dodge. That's what we need to add there. But let's do the rotation logic first. All right. And that's actually something that I want to go and get from our missile logic. So, how are we going to do it on time? We're pretty good on time. So I'm going to do something similar as what we are doing with our missile. So that actually means that we again, that's a good one, because now that we don't have a script, we also don't have a debug thingy. So that's one good reason to actually have a subscene there. So we are actually going to save this as a subscene. Okay. Let's go and say save branch as scene. Where are we? Models, states. There we go. All right. We haven't set up any signals here yet. We do need to change this, of course. No, what does that call that on the other ones? Just change state. All right. Is that underscore change state or change state? Yeah, change. So no underscore. All right. Keep going to my toolbar. So there we go. So that's important because that's the way that we allow it to call back into our parent logic to actually change the state. If we didn't do that, nothing would happen when we lose track of our target. Alrighty. So the reason that I wanted to have a subscript here is so that we can put in a mesh instance called debug, because I really want to visualize what we're flying towards. Is that actually smart? Because that's going to be right in front of us. It's going to block us a little bit. Maybe that's not the smartest thing to do. Well, let's see what happens. Might get in the way of us. We'll see. Let's not overdo it on the detail of a little ball. That thing is really, really big, which is fine. We might make it smaller. We'll see. And spatial material. This thing is going to be red. There we go. This is set it apart from the green that we had before. Okay. And obviously we want that to not be visible at the start. Okay. Which actually also means that I want my debug to be invisible when we lose track of something. I am going to start with putting a distance to target over here. Oh, that's probably a good idea. We want to start with getting our global transform so that we have access to that one. And then distance to target is going to be NPC position. Take away our target transform.origin. There we go. And we want to take the length. All right. Now, if our distance to target has become bigger than our, excuse me, did we just, that's a good one. That needs to be a new exporter. Let's name that radar range actually. This is actually not going to trigger a radar because we don't need that. But I'm going to make this one slightly more than our actual radar. So once we have a lock on a target and we go into our attack mode, we don't want to immediately lose it just because, you know, the target that we just detected is actually flying in such a way that they're flying away. So we want a little bit of leeway there. But once our target moves out of range by, in this case, 100 meters more than our radar range, then we're going to lose. We're going to lose tracking on that guy. So in this case, we're simply going to call set target no, and we're going to return. So we're going to go back to our follow path logic. Well, Godot better than Unity is, as I've said many times before, an incredibly subjective statement. There are objective truths in the sense of when you are building certain types of games, one engine might be missing features that would make it a less suitable engine for that purpose. But everything else, if the engine has the features that you need to make your game, it's no longer about whether Godot is objectively better or worse than Unity. It's all subjective. It's what applies to you, what you feel works best for you. And some people love the way that Unity organizes games and how you build games in Unity. It agrees more with them. They like it more. It's easier for them. So for them, Unity is a better choice. And then there are people who say that about Godot, who, like me, love the node structure in Godot, find the way that you organize your scenes in Godot much more suitable. And for me, one of the selling points for Godot is how fast your development cycle actually is. From writing code to running, testing, changing, because there's no compilation steps. You just run it and it runs. The integration of the scripts inside the engine, that's where I win a lot of time, because I just write the code much faster when I'm working in Godot than in any other engine that I've tried. So, but it's subjective. You can't really objectively answer it. Yeah, you can objectively answer if you want to do. Let's say that you want to build an open world game like Far Cry. You don't want to build that in Godot. Not something like that. You might not even want to build that in Unity. You might want to go for Unreal if that's your goal. But you also have to realize that if you're a one-man indie or even a three-man indie, you're a developer, an artist, and who's your third man? The guy who does the music and sound. You standard two-man, three-man indie. You don't have the capacity to do something on that scale anyway. So all of a sudden you gotta ask, is that the right tool? Now, I do say that a little too quickly. When you look at tools like Houdini and stuff, the scale at which a small team can nowadays build stuff, especially if you have really good, talented people, yeah, you can make some really impressive games. But at the end, it is the people that you have that really are far more important than the engine that you choose. Their skill sets, their abilities, and what they feel is the most natural environment for them to work in. And whether that, it's the same for graphic artists or 3D artists. There are people who swear by Maya. There are people who swear by 3ds Max. There are people who swear by Blender. All those tools are all incredibly good at what they do. You can't say which one is better. Which one is better is the one that you're the most experienced in. So that's my answer always to that. John, I like Godot. Can use GD file, script as JSON with data, everything you can just... Yeah, the load and preload functions and the logic behind that to figure out what it actually is that you're loading makes it really easy to build things. You don't have to know that whether you have to have different functions that you need to call. You load a JSON file, it's going to be it's going to return a JSON object. If you load a mesh file, it's going to return a mesh object. You return a script file, it's going to return a script object, etc., etc. Yeah, that is a a big truth. While there is more and more available on the Godot front, you have more and more people doing tutorials, especially when it comes to 2D. There obviously Godot is incredibly strong when it comes in the 2D community. There are so many 2D game developers that are currently working with Godot that you have such a mass of people that, you know, it's always a percentage game, right? So let's say that 1% of the people working on something will make the decision to contribute, whether it is contributing to improvements to the engine or whether it's contributing in the sense of doing YouTube tutorials or written tutorials. You know, 1% of 1,000 people is 10 people. 1% of 10,000 people is 100 people. So the bigger the group of people who use an engine is, the more people will be writing and making tutorials. And the easier it is to get into that. So when you look at both Unity and Unreal, there are so many people working with those game engines. Then yeah, there is so much more out there to look at, whether it is tutorials, whether it is assets on asset stores. So that is definitely something where those two engines currently are ahead of Godot. That said, that is changing, right? Godot is getting to a point where there are more and more people getting involved with it. It is going, you know, it's improving in popularity in an exponential rate. So you see more and more people doing tutorials and doing online things. But I do agree, there are far too few people doing 3D stuff. And of course, now for me, I am focusing on VR, although like a game like this, 99% of what I'm writing here is no different whether you are building this as a desktop game or whether you're building this as a VR game. There are so many concepts that overlap, and that is also why I think a lot of people enjoy what I do. Is even though, you know, I've got this VR element to it, there's so much in there that's still usable. But there are too few people who are on that bandwagon. I do agree, but it's growing. It is growing, so that's a matter of time. And indeed, yeah, it is free, it's open, and it's growing. You know, again, that's really the thing. You know, it is growing in popularity, and 2D is the best example of that. You know, go back 3 years, and you had 2 or 3 people doing 2D tutorials. You know, there was hardly anything out there. You know, GD Quest and Kids Can Cope. No, I'm not even sure if Kids Can Cope was doing tutorials 3 years ago. Might have just started around that time. Nowadays, you know, we got Game Endeavor, who's in our group right now, and we've got Heartbeast, and we've got Pig Dev, and there's so many people who are now making tutorials, and they're mostly focusing on 2D, sure, but you know, there's so much in there that already teaches you how to use this engine. Even if you want to do 3D stuff, I can still recommend anyone to follow a bunch of the 2D tutorials and videos up there, because a lot of the principles carry over. You know, so much that works exactly the same in 2D as it works in 3D. You just have one more dimension to take into account, but the principles are the same. So, all right. So yeah, actually, I want to go and put a remark in here as well. Target has died. Oops, has died. Let's clean up and return to our previous state. There we go. So that's really what I want to start with. Is because we're going to need this distance to target later on to do more things. Excuse me. So we're going to make sure that we keep moving forward now. I'm going to make a little note for myself here to do. Need to check if we are close. If so, and we're and enemy is moving away from us, adjust speed. If enemy is moving towards us. Change state to Dutch. So that's something that we need to add in there later. But yeah, for now we're just going to accelerate at a consistent thrust to try and go towards our enemy. So now steer towards our enemy, and then I'm going to remark here to do, and actually that's probably going to be in a process, which we currently don't support yet. Well, that's something that we need to add in. Decide to fire. So obviously, if we're close enough, if we're heading in the right direction, we want our enemy to start shooting at us. I'm not going to do that yet, but that is something that we're going to be taking care of. For now, we're just going to concentrate on our steer towards our enemy. So I want to make that very similar to how our missile works. So we already got our distance to target. That's what we all did. So we now need our velocity. In this case, our velocity we have access to. Actually, I also want to go here. Our target position is target trans. That way we have a variable that we can start using. Alrighty. So in this case, we can just go and call get velocity from there, because that's one thing that we've now added to our base friend or foe script. And excuse me, if our if we are actually moving, we are going to determine how long it's going to take us to get there and adjust our target position accordingly. So that's the same code that we did here. So we're going to calculate our time to target. Oops. All right. We also need to get the velocity of our targets, which we can get because again our target is an enemy and enemy record. So, yep. So distance to target divided by our velocity. So that gives us the time of travel towards our target, provided that we are not accelerating, which we are. But again, we're winging it in a certain way. And then we need to, no, that's not going to be far. We're going to go and change our target position. What did I actually call that for our missile logic? Because, yeah, just target position. So we're going to go and get our target's velocity, and we're going to multiply that by our target transform.basis.z. So that's our target's heading. Now we're just going to go and call our heading. Oh, yeah, no, we're going to use our get delta position. That's actually a better idea. So our delta position, oh, that's not going to call it our target itself. Our delta position is the actual amount of travel or distance we've traveled, or vector we've traveled in our last frame. So that's actually going to point to the current, even if we're not facing that way, that's going to give us our current velocity or our current heading, I should say. And we're going to multiply that by time to target. So we're going to take how fast is our target going times what is the direction that it's traveling in times the duration that we would take to reach our target. That's going to be where our target is going to be in that amount of time. So that's how we're going to adjust that positioning. All right. And if I'm not mistaken, that's where we're going to go and do our debug. Oh, that's the other thing that we needed to do. Is we need to go and put that under a node, because else it's going to be parented to our Is it slash or backslash? So yeah, so that's to disjoin it from our location, /. So now I can just copy this because it's going to be exactly the same. And we just, oh, that's just selected. I thought it was airing out. So there we go. We're going to go and update our debug. Again, that's stuff that I will clean up and we'll start removing out of everything. At that point in time, I probably don't need this to be a subscene anymore, but I'll deal with that when the time comes. All right. So now we know where our target will be in the time that it takes us to travel to the target. So that is the location that we're going to aim for. Now again, I'm going to be lazy here. And we're going to copy a little bit of the code here because it's all going to be the same. And this is really stuff that I should start putting into functions that we can reuse. Like I also said, is I actually want the missile to start using our AI logic as well, our state machine as well. So it's very possible that we're going to be using exactly the same thing here. But yeah, because almost everything is going to be the same here. So good chance that I'll start using the exact same object here for our missile. And then probably add a few things specific to our missile logic. But yeah. Alrighty, where are we now? Target, target heading. Didn't we already have that one? New position. Oh yeah, that's because I needed our new version. So that's going to now be our NPCs position. So this is getting our vector from our current location to where we think our enemy is going to be. That's our first heading that we have. And then we have our NPC facing. That's our heading. And we're going to take the cross product so that we know what we are... why am I actually taking the cross? Oh, because that's going to be what we're applying our torque for. That gives us the direction of turn. And our dot product obviously gives us our cosine of those two vectors, right? Our direction that we're moving and the direction towards our enemy. We get our dot product gives us our cosine angle between those. And our cross product gives us our perpendicular vector on that, which either points up or down, depending on whether we need to turn right or whether we need to turn left. And that is what we're going to then be doing with our apply torque impulse. And that is something that we call on our NPC, not on ourselves. And there we go. So that should mean that our enemy is going to start turning towards us. It's not going to shoot at us yet. It's not going to lose us. It's going to just keep on flying towards us, and it probably will bump into us if we're not careful. So this is going to be fun. It's going to try and just ram us, I think, at this point in time. Let us see if we've made any mistakes. We probably have. And did we crash? Yes, we did. All right. So I was kind of expecting that because my auto-completion wasn't working. And therefore you can make typos without knowing that you are making typos. And we get another one. Okay, there we go. Length not found. That is a function. I'm surprised that that one didn't error out in our editing as well, actually, to be honest. Alright, so far so good. Alright. Alright, this is interesting. Our ships aren't moving around their trajectory, but he's decided to actually start moving now. I don't think he is trying to target us. Alright, so we are missing something. Let's have a look at what we're missing. Now, okay, I think it is time we start writing some stuff into here to help us figure out what is going on. So the first thing that we're going to be doing is in our follow path, setting our radar range, and we're setting our collision mass. Now let's double check if that's still set correctly, because that's going to be the first thing to look at. Yeah, our collision mask is still set. We still have a radar range. Hey, Siradev. Welcome to the stream. Alright, so that bit is supposed to work. Oh. So, we've got our closest, found closest. So let's go and do a print here. Found new targets. I'll just print the name of, actually I don't need to convert that to name because that is a string, or I don't need to convert it to string. So let's go and tell us that we have indeed found that, and then we go and emit the signal. So there we go, and that signal is linked up to our AI follow path found target. We are going to set our state to our target, and then we're going to change our state to our AI attack. So let's go and record that. Print. I've been doing too much JavaScript today. So lost targets dot name. Again, we don't get that, or when we've died, we get that in time. Found targets, and here we're going to go and say clear targets, and of course here we then don't get a name. So that will hopefully tell us something about whether it is actually heading towards us. All right. Let's go and see if that works. I'm actually not going to put my Okay, that's interesting. It is constantly going back and forth. That's interesting. Oh. Okay, how are we going to do that? All right, well, I am thwarted by my own logic. That's interesting. How are we going to solve that? The way that we're going to solve that is we're going to start working around changing some stuff. Okay. So the problem that we have is that on our follow path, we now have our radar. But our follow path is currently a normal node class. It's not a spatial based class. And therefore, our radar is always at the origin point of our world. It's not at our at where our unit is. So we actually need to make sure that all our AI is based on spatial nodes, not on node nodes, because we do want to get information about our positioning. So let's see if we can make that work by just changing a few things, or whether we actually need to go and do a lot of behind the scenes work. Now that one we can just change spatial without any problem, but that was all my tutorial stuff. That's not what I was after. Where are my games. We are going to have to fix up our base one. So, oh, look at that. I actually don't have them as, all right, that's interesting. So where is our root node here? Type node. So that's going to be type spatial. All right. That means this guy is going to be type spatial. That means this guy is going to be type spatial. And now in our character scripts, save these guys. Yeah. They are child scene, so they immediately go and get changed. It also means that this guy needs to change. Okay. That's going to be interesting. That one I think we can do in here. Let's have a look. Actually, I could have probably changed those in the interface as well. Where's my... here we go. Render file. So... no, it's in our AI one. Our AI logic. So... change type. We want this guy to be a spatial as well. Oops. Oh, because I selected my animation player. Oops. Yeah, that's not gonna work. I hope that didn't screw anything up. Idle. Yeah. Let's move it back to idle. Okay. So that should mean that we now have those as normal spatials. Of course, in here, there's now our radar, which is a good way around. But here, target helper, that one, I think. No, that's that one. So didn't I have a debug one in here? I thought I had a debug thing. Oh, I already took that out. That's right. So I can actually remove that as well. Okay, all good. So it's purely on our attack scene that we now have our debug node, and we have that underneath that. All right, let's see if we were correct and if things still run. Yeah, people always like mispronouncing names, that's for sure. Okay. All right. Our guys are really flying over there. Let's see if they change their behavior now when we get close enough. Now our right plane should try and attack us, while the left plane should just start following. Now I see my red dots already, which is interesting. Okay. All right. Well, it's trying to follow me, but because we gave it such a... All right. So where is our friend? He's way off, I think. Oh, those are those guys. Well, he's still trying to fly at me, but... actually, let's see if we can get away from him. So yeah, like I said, that was the thing that I was worried about. That red dot obviously is going to be pointing to where our enemy is expecting us to be at some point in time. So it's always going to be in front of us. There we go. And it's just lost it. So the fact that that red dot disappeared means that they have now... Now, I've flown away far enough. And we can see that they are now rejoining their path. All right. So our big problem that we have is that it's 500 meters that we've configured is way, way, way too close. Because by the time that it's trying to fly towards us, our target was already in front of it, and that's why he didn't turn much, because he was expecting us to. And that's actually interesting, because that also means that we should only be adjusting our distance to target if it's actually flying towards us. So yeah, that's something I need to think about. Anyway, I think what we're going to be doing is we're going to make that a little bit more. And we're going to make that a little bit more. And we're going to see if that behavior means that it's not actually going to start attacking us. The nice thing about that red dot, though, is that it does mean that we can immediately see when it targets us, because we get a red dot at that point in time. Well, it's not picking me up yet. Oh, now it suddenly decides to go at me. There we go. All right, that's interesting. Well, it's trying to follow me now. It's definitely trying to chase me. But yeah, this is still that he detected me way too late. So now that could be because no, this is all over here. So now the worry that I have is that if we put it on that, it's going to, oops, it's going to attack us right away, because I don't think they are that far away from our ship. We'll see, because that's the same radar range that we have. Now, they're not immediately on our radar, so this means that the moment that we detect it, they also detect us. Although it doesn't seem to do that. That is really strange. Or did I increase my radar range? I can't remember. I think I did. So, okay. That was about halfway. My radar globe is set to 1,000, while my detection is 2,000. That means that our overrule here isn't being applied. That is interesting. Why not? Why is this not actually updating this? Let me see. Because that is being set in our ready. Ha, okay, so this needs to have a set radar range. That needs to have a function for that. Okay. That is why. All right. So we're going to start with that. So here we copy it again. And that means that we can go and move this into here. And we obviously need to make sure that we only apply that once it is loaded. All right, let's see if that makes a difference. All right. Well, they're doing something. I can see my red dot going way in the distance. All right. Well, it's definitely not doing what it's supposed to be doing yet. Bye-bye. But why? It did detect us now. Oh, boink. Ah! But the thing is overcorrecting. Because you look how far that is... Oh, yeah, you're flying at me now, don't you? So he's definitely trying to fly towards me. We're stuck on each other's bubble now. I think I've got them all four on my tail now. Yes, I do. They're all following me. Okay, so I increased the radar range a little bit too much now. They are trying to fly towards me. But... well, they're trying their best. That's all I can say. Now, one thing that could be interesting. Let's go and see if we can actually fly out of their range. But I think that's my problem right now, is maybe I need to limit how far forward we project that. I'm just waiting for the little red ball to disappear. Because that means that they've lost track of me. Actually, that should also mean that they're no longer in my globe. They're pretty good at chasing me, that's for sure. Come on. Alright, so I got one of these guys selected. Eventually, it should disappear. I wonder if they are almost as fast as I am. There we go. That's interesting. I'm no longer on my globe. Alright. Well, I'm not seeing my red dot reappear. So that would suggest that they are now all, they're far away from each other, so they're not following me anymore. They're going back to their patrol route. Okay. Let's see when I start getting close enough that they start seeing me again. Okay, they see me. It's funny how I control that red ball depending on how fast I'm flying. Okay, these guys are definitely coming too close to me. Oh. Ooh, that was loud. That was loud. Alright, so in principle it seems to work. But the problem that I'm having is that when they're flying away from me, the adjustment of that was a radar. So I think our biggest problem that we have right now is that we're adjusting our target position, but we're basing this logic on the assumption that they're already flying towards us. And therefore they're trying to meet up with where we think we're going to be if they keep heading towards us. The other thing, of course, is that ideally they don't actually want to hit us. They want to stay behind us some distance. So that's something that we can do to adjust it, because they'll want to try and tail us. That is a good question. Okay. So I think one of the first things that we could do is that we already change the target position that we're aiming for to be slightly behind our actual target. Because when I'm trying to attack the target, I don't want to try and intercept, I want to try and get behind it. And assuming that my target is, is either going as fast as I am or faster, I can try and get behind that person. Yeah, let's try that first. Okay. Actually, I'm happy enough to leave that the way that it is. So, in this case, what we want to do is target position, and we actually want to subtract our and this time we do want to use our transfer basis Z, so that's the way that the target is facing, and let's introduce a new variable called target distance. Actually, we're going to call it target follow distance. That's what we're aiming to do. And we're going to try and follow 50 meters behind our target. That's a good position to start shooting at him, I think. The other thing that I want to do, actually, we're going to go and default that to 11. And that means that we're going to default this guy to 10. Which then means that on this guy, we're going to go and change that back to default values. There we go. That hopefully means that we also won't get all 4 of our targets following us all at the same time. Okay. Oops. Let's see when they try and figure out that I'm close enough to them. There we go. They figured it out. So he's turning. He's trying to get behind me now. trying. Once he's behind me, he's actually behaving quite nicely. Now, his wingman isn't. His wingman is having a lot of problems keeping up with him now. And the other guys are still there. So yeah, he's trying to stay on my tail. Poor guy. It's more fun when they're trying to actually get behind me. I am faster in turning, though. Whoa, I hit him. Here we are. What are you trying to do? Wow, this is harder than it looks. All right. Now, one thing that I'm wondering about is if it really makes sense to adjust where I'm going, or whether I should just tell him to always... Whoa! Okay, so that's where it's going to become important that we need to add that evade logic in. There we go. We're circling around each other now. Whee! Gotcha. Whoa! This is fun. This is actually a lot of fun. Whoa! Where are you going, buddy? Where'd you go? Oh, there. So yeah, we're trading places now. He's pretty maneuverable. Yee! So that's obviously one of the things that is going to be... Oh! Yeah, we're going to have to implement that dodge logic soon. Because he's just trying to ram me now, because he's just trying to get behind me. Whee! It's fun flying in space where you can just turn around on a dime. And I got him. Alright. So it's a little bit weird when he's still facing away from me. And he suddenly decided to fly towards me. He's just trying his best to just turn around. And especially because I'm still going full throttle towards him. The target position is in front of me. Because that's where he expects me to be by the time that he catches up. But of course, by now he's going in the opposite direction, so he's going to either try and ram me or he's going to overshoot me. So, okay. Let's go and start working on also handling our process in our AI. So we're going to be doing the same thing here. I'm just going to go and copy this and just rename that to physics process, which means this is going to call physics process. And that allows us to create our own physics process logic. All right. So our points. We're just going to give this guy, even though it's officially a bomber, we're just going to give this guy 2 lasers to shoot with. And I think those are his cannons. So those are going to be his laser cannons. Hardpoints. Alrighty. Here we go. There's hardpoint 1. I want to make absolutely nicely in here. There we go. Alright. So that's going to be a gun hardpoint. That's number 1. We're going to make number 2, which is then going to be on the other side. And I'm going to hope that that is nicely centered. Yeah. Cool. Our ship is pretty symmetrical. That makes life a lot easier. Actually, I want to move them slightly forward. There we go. Cool. Let's add our laser to it. That's our first laser. And in this case, that guy is going to be fired by our enemy. Cool. And let's give him a second laser. There we go. So he is now going to be able to fire. All right. Now I think all that we're going to do right now is we're going to make him figure out how close he is to us. And when he's close enough, he's just going to fire his lasers. I think that would be actually cool enough to implement. Just as a starting point. I think that would work out nicely. All right, so something I want to quickly have a look at, and that's probably over here. Ready? Shields. So we don't actually have any fire logic here. So we're just doing that in our plane, I think. So we're doing that as target input, handle lock, handle fire input. So all we're doing here right now is we're just firing. Okay. Let's make our AI do exactly that. I think that would be fun. I don't know if I can take damage yet, actually. I don't think I've got a health. We'll see. We'll see if he can actually kill me. Because, no, I do have to take damage, so kind of wonder what happens when we die. Does the game just stop? I think we might actually end up crashing. That'll be interesting. We'll have a look at what happens. All right, so we want to go and copy our handle process into our attack script. And I already said move to process. There you go. Okay. All right. So all we're going to do here is if we have a target, which we should have, I don't actually need more than just the position here, so nope, that wasn't what I had in mind. All right, then we are going to go and copy this. So one of the things that we should do here, which I'm not going to do yet, is that we really only want to fire if we're actually facing in the right direction. This guy, if he's close enough to us, he's just gonna fire away. Even if he's gonna face away from me, he's gonna fire. And we will definitely improve on that, probably in a minute. But for now, I just want him to fire the gun. So need to add check whether we should fire. Now remember, there's a cooldown on our guns, so he's just going to rapid fire or try to rapid fire this gun, but of course he can't because of the cooldown. So most of the times that he's trying to fire, it's not going to do anything because the gun hasn't cooled down yet. Oh, my machine is frozen. Come on. There we go. Happens sometimes. So I'm actually going to go and just copy that. And we're going to go just paste that in, because that's all going to work the same way. We do need our delta position, so that's actually something that we're going to go. That's actually our delta velocity. Do I have that? Is that one of the things that I store here? I get the velocity, that's the length, but I need the actual vector. There we go, delta position. Because we can't use our delta in our so well, I could do it that way. Yeah, well, that'll work. That'll work. Okay. And I actually want to keep that here. So you can actually move that in here as well. So var NPC so now we need to do our NPC here. So we're going to get our velocity in speed per second, and we're going to get our direction of movement but normalized, and that is then our velocity as a vector, which we can set to this guy. And then this guy, or we can just send our target. That's fine because it's not going to be import for here. So we don't have any rockets on this guy yet. Obviously, we'll want to have those where the logic becomes just as simple, where we just implement our radar. All right. That's actually an interesting one. When we look at our follow path, we probably want to also make sure that if our follow path is hold on, where's our base state? So we've got our enter and exit, so we can implement on our follow path and enter and exit to make sure that our radar gets turned off. Right now our radar is always working, even if we're not using it. So, or we move the radar to the NPC and access it that way. That's another option. That's something I need to think about. So in this case, we're just going to keep firing as often as we can. Oh, we wanted to get a distance in there. So let's go and say export float var fire distance. And let's say that we're going to start firing if we're closer than 300 meters. If distance to targets is smaller than fire distance, then we're going to go and fire our primary weapons. And obviously if we add missiles to this guy, we're going to add some similar logic here where we're going to say, okay, if we get target lock, we're going to go and keep firing. And that's another reason to see if we can go and make the target lock logic somewhere more centralized. But hey, it's a first try at this, right? This is just getting things to work, and then we're going to start prettying it up and make it work better. So let's go and see if our enemies are now going to try and start shooting at us, and let's see if our game crashes if they actually succeed in shooting at us. Okay, let's go. Let's go, let's go, let's go. Alright, so we figured out that I'm here. I'm going to try and turn around. The overshot. Oh. Something went wrong. How come? Alright, so that's right, because... Okay, this is getting a little ugly. This is definitely something we need to move that logic into a function on our NPC. So, and because we have this in both places, that is definitely something that we're going to do. Not yet. All right. Well, he's trying to fire. That's funny. Whoa! So like I said, we need to change it so that he only fires when he's actually facing us. Although he's having a hell of a time to try and do that. It's fun though. Oh, he shot his own wingman. That's hilarious. That is really hilarious. Well, he definitely is not a very... Oh, I hit the wingman again. Oh, okay. Okay, he shot me a few times now. Okay. Whoa. Yeah, he is having a lot of problems right now. Okay. I think we need to make this, we need to break this up in a couple of steps. I think we need to introduce a couple of states that our enemy is going to be in as he does his attack run. So when the first target locks on us, he's going to turn around and he's going to try and get behind us. So that's the logic that we're in a relatively good spot of doing. And when he's doing that, when he's flying towards us because he wants to try and overtake us and get behind us, obviously if he's facing us and he gets a shot off, then he should be firing. But once he's behind us, I think he needs to go into a different set of logic, because instead of... Because you can see that he had a lot of problems actually turning correctly. And because we now have our, we're flying this way, and we're moving our target position behind, because that's where we want him to try and get to, so that when we're flying, that he gets behind us and he starts shooting at us. But if he manages to get there right now, he's going to overshoot it and he's going to turn away from it again. So he's never actually going to be facing the way that we are so that he can take a shot at us. So at some point, when he's behind us, he needs to switch to a follow mode, where he's trying to follow us in a way that he can actually start shooting at us. Now, part of the problem, of course, is that we don't, and he's fully gunning it at all time. So right now he is not trying to match our speed, which is why he always overtakes us. So in theory, if we would be standing still, he would try and fly in behind us, slow down, and then turn towards us and then start shooting. So I think first of all we need to improve the logic a lot on it figuring out, trying to get into that behind position and trying to keep facing where we are instead of trying to face. Well, I guess he still wants to try and face where we're going. And I also think that we need to change the way that it tries to do, whether it's facing us or whether we're flying away from it. So that's also, I think, an important thing, is that if we're heading towards it, and that's the two states that we need to have. We need to have a state where our enemy is trying to fly towards us. So if we're facing each other, then he has the normal state where he's trying to get behind us, and he only gets a shot off if he is actually facing us. But when he is behind us, we get different logic. We really, he really starts to try and get onto that. He really tries to follow us. And I think in that respect, the logic that we now wrote, where we are moving our target forward to where we're flying to, becomes more important for that. So when he's trying to fly towards us, we're purely looking at that place behind us where he wants to end up. He wants to, and maybe even when we're still facing the same way, we even want to sort of like overshoot that, because he's still going to have to go and take a turn before he actually faces us. And then once he's behind us and he's facing the same, we're almost flying in the same direction. That's when we go into the attack target mode that we have right now. Yeah, let's just try and see if that improves things. Because the other thing that I'm wondering about is when we look at the logic to try and get behind us, is that we don't have that evade logic yet, right? If we are going, if we're playing chicken, then there has to be a point where it figures out, like, I'm heading directly toward each other. I now want to go, and I want to dodge. I want to go in a different direction for a little bit, and then get back to where I was. Yeah, I think that's what we're going to do. All right. Okay. All right. Oh, let's go and have a look. I'm going to go close all of my tabs again because it's getting a little bit crazy. So that means that we're going to go, let's just do it like this time. I'm just going to add a spatial node. Boom. I'm going to call that AI get behind target. There we go. Scenes, no. Models. I need to organize this a little better. So that's our base, and then we're going to go and do extend scripts. Actually, let's go and save this first. Yep. And now we can go here and say extend script. There we go. Cool. All right. First things first. Look up a change state so that we can change the state. Boom. All right. Now, for now, I am going to go and copy all this. Oops. And I'm going to put that in here. Again, I need to find a way to I need to find a way to go and put these to put some of this stuff more centralized, because I keep having to, well, do I actually? That's actually a good question, because some of these actually are behavioral things as well, so we'll see. All right, target, trend of foe, cut off, all units. We'll clean up a little bit more in a minute. So we're first going to go over here, and here we're going to go say we're going to keep that, because if we are going to use that, we're going to do that too. Get behind targets. There we go. Or are we going to do that if? No, we're going to go and do that if we change. So we're just going to go. Oops, and change that like that. So instead of switching over to our attack target, we're going to switch over to our get behind target script. All right. So now we're going to simplify this. So we got all the same stuff with this. That's all going to stay the same. But in this case, we're going to go say, yeah, so that's going to still do our radar range check. We're not going to be doing that in our get behind, because we're already going to be in a position that we know, in our attack target, because then we're going to know that we're still following, and we're going to exit our attack target if we aren't in that cone that we're moving to. Although maybe we have to, we'll see. So in this case, we're actually going to go and keep gunning it. Although we are going to also be checking our dodge logic in a minute. So now we're just going to go and gun it. So we're going to go here to do add logic if we get close and we're ramming our target. Now, one of the things that's going to be interesting is we actually need to enhance this logic as well to avoid other objects. So we might actually make a dodge thing that we do even before any of this, that whenever we detect that we're about to hit something, maybe with an area that we point forward, we're always going to do a dodge. And we might even do that in our NPC itself. So that might actually end up in our bomber, where we just have a volume in front that we're checking, and that if we are at risk of hitting anything, we immediately put a AI dodge on our stack, which will stop doing whatever the craft is doing, and it will just go and dodge. So I have to have a think about how we're going to do that. So that might not end up in the logic here. I think actually that isn't going to be in the logic here. So here we're going to adjust our target to be behind. And in this case, we're going to completely ignore that. So that actually also means that we are not really caring about about our debug thing. So, oh, I never made it, so that's fine. Okay, cool. All right, so let's see. Distance for targets. It's fine. Then get up target heading. And we're going to do our normal steering logic that we already have. Alrighty. Okay. Now in this case, we're not going to do any firing at the moment. We're just going to see if we can get this guy to get behind us. All right. And we'll deal with switching to our attack target states in a bit. So now we're just first going to see, is our enemy now going to try and keep behind us at the moment. Now it doesn't do any speed change, so it's only going to stay nicely behind us if we actually have a bit of speed. But let's see what it does. So now it's no longer trying to figure out where we are. So at some point it's just going to say, try and get behind. Now that's a problem, of course, is that we don't have any way to know how fast we're going. Now I'm going to do something crazy. Stand up. And we're seeing that we're being followed. Now they're going faster than we are, so he's going to hit me. Boom. That's okay. Alright, see if I can feel where my thing is. See if we can speed up a little bit. So he's turning. Oh, we're going into the asteroid field. That's probably not such a good idea. Where's my... There we go. This is, of course, the fun thing about being in VR is we don't have any checks yet whether we can stay. Yeah, they are following quite nicely. Where's my... That's pretty scary because I don't know. Oh, he's gaining on me again, so let's speed up a little bit. I'm going faster, bye bye. Alright. Well, they're nicely trying to follow me, though. That's pretty cool. Oh, their friends are following us too now. We got a whole bunch of bogies on our tail. Cool. I love that engine effect. All right. So, there you go. All right. So our follow logic is working. Yeah, I was standing up because that was the only way that I could look over my shoulder and look behind us. So, yeah. So yeah, you probably had me cut off. That is, yeah. I need to, at some point, I need to have a second camera. And then if I do something like that, I actually need to switch to a second camera so you can have a standing up view of me. I guess. because obviously I have been doing everything sitting down. That's really the only way that I can, well, do something that I'm not supposed to do. So one of the things that I still want to build that I haven't done yet is that if our, and I've done this in the racing game, if we step outside of our cockpit, if our head is no longer inside of our cockpit, we need to fade to black or something like that, or make it very clear to the user, like go and sit back down, or something like that. So yeah, that was a nice little trick to actually be able to to look behind me and see what was going on. So we could see that our enemies was following. So I hope that that actually works. Yeah, I can actually. One of the things that I could have done, I might actually do that, just to give it a try. All right. Because of course I couldn't really see what you guys were seeing. Okay, they're trying to get behind me. Do it like this. So now I can see what you guys are seeing. So I'm just holding my headset up. There you go. So we can see that our enemies are nicely trying to stay behind us. Now that only works if I'm actually flying faster than they are, because if I'm slowing down, then eventually they will overtake me. Woo! Good thing that I ducked. And you can see that they are now trying to... Oh, this is hard. They're trying to get behind me again. We're gonna fly far away from our... Oh, I need to do everything in reverse. That is really hard. Oh, yeah, what was this? Oh, our debug. So we got out of range of them. It's good. But we still had our debug node code in there, which we are no longer using here. All right. So this logic is still, full gun ho. It's trying to get behind me. So, all right. All right. All right. So now we're going to thanks, guys. Much appreciated. All right. So now we need to detect whether we're actually behind and then switch to our attack mode. And then in our attack mode, we're going to simplify a lot of things that we're going to try and stay behind. We're going to try and match speed. But the moment that we are no longer behind, or we're no longer facing the right direction, we're going to switch back to get behind target. Now, the first thing that we need to do is we need to see if we are actually heading in the right direction. So if we're heading towards that point, because if we're still steering away, if we're still facing away from where, we might be, I might be here and the enemy might be there. So we're both flying in the same direction, but we're not where we want to be. So at this point in time, we're still turning, we're still trying to get to that behind position. But the moment that we are facing our location, so we're at this point where this value becomes pretty small, or well, close to 1, I should say. Then there are two options. One is I'm still heading towards it, so I'm still trying to overshoot to get behind. Then we need to keep going. Or I am now behind him. I'm actually trying to fly towards that dot, and I'm facing in the same direction. And that is the moment that we want to switch to the attack target mode. So we're going to set up a couple of variables here. That's a follow distance. This actually needs to move because that's our fire distance, which is no longer applicable here. Although at some point in time we might indeed do it if we're facing each other, right? That we at some point are going to try and fire. So yeah, we will see. All right. So we're actually going to rename it the target distance. So if we're closer than 300, that's the first thing that we're going to aim for. And the other thing that we're going to aim for is our target angle. So let's say 25 degrees. So we want to be within 25 degrees of looking towards him. All right. And obviously we want to then have a on ready var here, which is target. That's not really churn. Course, I'm just gonna call it like that. Thing needs to have a name. Target angle. So again, that's the human readable value, 25 degrees. That's something that makes sense to us. We're converting that to radians because that's what math wants. And then we're taking the cosine of that, and that gives us a value. And as long as we're bigger than that value, we know that we're within that 25 degrees. If we're larger, then we're somewhere on that other half of it. All right. So the first thing that we need to do is to check if distance to target is smaller than do I really want to call that target distance? I'm going to call that minimum target distance. Minimum target distance. So that's check number 1. And dot smaller than, and actually I'm going to go and make that a new one ready var and say 90 cos back to rad 90. So 90 is halfway, right? So 90 that way, 90 that way. So that means we're facing. Actually, I don't even need to know that because that's always 0. So if dot is bigger than 0, yeah, no. So that means that that we are. What I'm thinking about that we are facing somewhat towards where we're heading, so we're not moving away from our enemy. Maybe I'll make that smaller at some point in time. And then the last thing that I want to do is take NPC facing dot, and now I need my target facing. Do I have a target facing yet? I do not have a target facing, but I do have my target transform. So target transform. Oh, there we go. And not facing, that's facing. Let's see if my autocompletion wants to work now. Yeah, it does. Basis.z. So if that is bigger than our target angle costs. All right. I don't like that, does it? Don't like the indentation here, but we'll live with it for now. Oh, Wybie, thank you for joining. Have a great day over there in Europe. Don't know if it's the beginning of the day for you guys. I'm guessing. All right, so if we're close enough, and we are at least facing towards our target, you know, or our point that we're going, and if we are within that 25 degrees of what heading our target has. Those are the 3 factors that we're checking. So if those three things are true, then we're pretty much somewhere behind. That's the thing that we're trying to do here. So if we are somewhere behind, we want to go and attack. All right. Now, one thing that I want to have a look at is follow path. Yeah, so that's what do we do if we do found target. So here we're going to do a new signal, and we're going to say behind target. So basically we're going to give a signal once we are behind our target. Emit signal behind target. And then we're just going to give it a target again. So we're going to pass the target down our stack. Cool. That now means that on our get behind, actually I want to make sure that that's so that we get sort of like an order there. So we can go and connect that one. Boom. I'm just going to copy those lines, but instead we're going to say AI attack target. AI attack target. And again, here I've got the problem that I really wish that we had some of these things. Some of these things. What did I want to say? No, in a more central place. Okay. So in this case, actually, thrust force is going to end up being a max force because we want to try and stay behind. What time is it? Because I'm getting pretty tired. Oh, it's 12:15 already. Okay, we're gonna see if we can finish this last bit of logic. Won't have to be part perfect, but I am losing focus. I'm getting a little bit too tired. All right, so we're gonna keep most of this the same, but we are gonna change a few things. Okay. So in this case, once our distance to targets becomes bigger than a radar range, again, we're going out, then the set target. This would change it back to our behind target logic, which then in its next process handling will also determine that we're too far behind, and it'll completely drop out. So that's fine. Not too worried about that. Actually, to be honest, what I think is a much better idea here is that we're actually going to take that out, and we're just purely going to do that on the fire distance. So if we found that we've fallen too far behind, or we're getting too far out of range of our target, we're going to get out of here. We're going to get back to our get behind target, and our get behind target is going to gun it and try and get where we need to be again. So we don't need our radar range there because that's a much smaller thing. So if we try and gun it out of there, and he's also going to stop shooting at that point in time. So that's pretty neat. All right. So this is going to be changing. So here we're going to go to do try and match speed. There we go. Now in this case, we're not going to adjust position because we are fully wanting to do the logic that we wrote here. So we're not going to try and get to our actually, that's a good one. What we're simply going to do here is if distance to target smaller than, let's say, fire times 0.5. All right, so if we are getting, so our fire distance is 300. Actually, is that? No, let's actually use our follow distance for that. That's actually probably a better idea. So if we get closer to our target and our follow distance, we're just going to cut our engine out. And if we get further behind, we got it again. I think I've done the same thing in our wingman logic. Did I improve that yet? I'm not sure. Let's have a quick look. Yeah, I just did there that if I fall behind the distance, I just gun it. I'm not doing... No, I am. I am doing actually a little a little speed limiter there. So let's actually go and boom. Let's go and copy that, because that actually was a really nice bit of logic. So here we're actually going to say distance to target. Is that expressed as a factor of? Hold on. Oh, that's the distance as expressed as. Okay, that's okay. So if our distance to target is smaller, so let's say, so our target distance is 50, so that's our, and that should actually be follow distance. There we go. All right. Okay. So what we're doing here is, let's say that we are closer. So we're too close. So we're at 40. 40 divided by 50 is, what is it, 0.8? Oh, that's actually interesting, because that would mean that when it hits, it becomes 0. How interesting is that? That is because we do that target helper here. Okay, hang on. This is a target. I gotta follow distance. But we are calculating our distance to. So should I do that? Yeah, I think I need to actually. No, that would be the adjusted target distance. That's the problem. How am I doing that here? Let's see. Ah, that's what I did there. Okay. You know what? We're not going to do that here. I'm going to think about that some more. Oops. So this is distance to targets bigger than distance. Okay. So the idea there was that I've got a helper node there to see how far behind and to the left I want the wingman to be. So the wingman measures its position in relation to that. So if it's exactly there, it's going to be 0. If it's going to be more forward, it's going to go into the negative. So it's going to be minus 50, for instance, if it's too far forward. If it follows back, it's going to be, 50, 100, however far back it is. And all that I'm doing there is that I'm dividing that by our target distance so that you get a factor as expressed by the target distance. So if he is exactly, let's say 10 meters behind where he should be, he's gunning full speed. But the closer he gets, the less throttle he gives until he's exactly there, and he gives no more throttle, and he's gonna oscillate at that point in time. Now, again, that's really not actually what we want to do. That logic definitely needs to be improved, because if we know the acceleration of our target that we're following, we can adjust our impulse accordingly, so that we can try and really match speed when we're on that at 0 distance. So for now, we're just going to fully gun it when we're behind. In the moment that we are close enough, we're going to stop. So he's going to keep his momentum going, get too close, but he's no longer throttling. So provided that we are still moving, he's eventually going to fall behind again. So yeah, that is how this is going to work. So they're going to oscillate a little bit as they try and follow us. So we are gonna set a target from where we're steering to somewhere in front of us, so that actually we're trying to aim towards that. And if we are And we're going to steer towards that point. So that's what we're doing there. So we are moving here. We're now behind it, and we're going to keep moving there. Now I'm going to go and comment out. Can I do it like this? No, that doesn't work in GD scripts. I'm going to comment out the shooting logic for now, because I want to see if right now our enemies are going to go behind us and they're going to actually sort of stick there, even if we slow down, and see how well they try and keep following us. I'll try and do that the same way that I just did by holding this up. It was a bit annoying to do, but that way I can see what you guys are seeing, and that way we can really see whether our enemy is following. And of course, I still need to do something about that problem. Everything in good time. All that was happening there is that my starting input from my joystick was causing my actually, let's just there. It's causing my ship's shield to hit the inside of our carrier, with the result that we hit the ground of the carrier and started rolling like a ball, because our shield is a ball. All right, so we should now have these guys trying to follow us. Where are you guys? All right, they are definitely there. Actually, I want to go the other way, Aaron, as we're going to pick up the other guys. So they are still trying to follow. All right. Now I'm going faster than they are because I've got more power. That's why we're pulling away. So I have throttled back, and I want to see if they come close and whether they're now going to try and stay there, or are they going to hit me? They are still hitting me. But after that, he is trying to, you can see how he gets close and then falls behind, and gets close and falls behind. And that's that logic that I wrote, right? Where he's gunning it and he's cutting his engine. And he's gunning it and he's cutting his engine. So obviously that's something that we want to make simpler. And now, because he guns it too much, there's not enough space for him to brake. That is why he hit us. That's interesting. Okay, but the principle is there. Alrighty. That is close to what we wanted to do. So I think our follow distance, we actually don't want them to get that close. So we're going to make that 100. Which means that in our get behind, we actually also want to make that 100, because that's where we want them to try and get to. That'll be interesting. All right, so all right. Now the first thing, or the next thing that we need to do is we actually need to reintroduce our target angle. But again, just like in other places, we want a margin of error here. So we're going to make this bigger than it is in our, because else we're going to start flip-flopping between the two. That also means that we are going to go and copy our target angle cos. I actually need to make that a naming convention, I think. So here what we're going to do is we're going to say, well, if our dot is smaller than cutoff, that's just our little margin that we no longer start steering. And one of the things that I really want to do here as well is actually the bigger the angle is that we need to steer, the more steering force we give. The other thing that I want to do here is I want to add something where we're trying to reorientate to be in the same plane as our enemy. So instead of now one ship flying like this and one ship flying like this, so if I'm following this guy, I'm going to try and rotate to match the way that the other guy is facing. Okay. So if we're going, oops, if we're going the other way around, now this is interesting. No, that's right. So, because it always works the other way around. I always forget this. Because 1 is facing the same way, and then we're going to throw smaller until 0, -1. So what we need to do here is, if we're smaller than that target angle, that means that we're further behind. And in that case, where did we already? We're just going to go under this. Boom. Oops. There. Cool. So in the situation that we are no longer behind and we have fallen too far, we're going to switch back to our get behind target logic, and we're going to start following as per normal again. So that completes all our logic as far as that. I do want to improve this so that we're not gunning it all the time. But I think that is pretty much the logic that we want to have here. So, first thing that I want to do before I do any more with that logic is we're going to put the logic for firing our weapons in our friend or foe logic. Oh, I do need to open it. There we go. And that also means that I want to go and get my plain logic ready. Okay. So instead of copying all this logic every time, we're going to put that logic into our base script. And right now it's just going to fire all weapons of a certain type, but eventually that's where we can then also set firing modes, so that we can either have firing groups at some point in time, or we can have cycling between guns. So that will be the next. Hey, Gogarts, how are you going? Nice of you to join. Who's an aggressive driver? I'm me. So let's go and copy these guys. And we're going to move that in here. Now, this is the other thing I need to do. Yeah, so that all the information is available in here. So we're actually gonna, let's go and just put it over here. At some point I need to organize these things a bit better. So fire weapons. That's going to take something in a minute, but for now it's just going to go boom, 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 boom. And I'm going to go and give this an action string. Give string. And I'm going to go say action. There we go. All right. Delta floats. If it needs a delta, then it needs a delta. And I think I need a target here as well. So target, friend, or foe. And I might improve that at some point in time and figure out a little bit more what we want to do there. But for now, I think that is pretty sweet. So that means that we should be able to just do fire weapons, primary fire. Again, I'm surprised that we're not getting any help from our logic. Anyway. So right now I have linked that to our actions, but eventually we're probably going to do fire groups and link that to that. So that's how we're going to go and fire our weapons. Cool. Let's go have a look and see if that still works, if we can still fire something. You bet you I broke something. Oh, that was surprising. Just works. All right, cool. So now we've moved that logic successfully to our base script. we can do the same thing here. So instead of what we're doing here, we're just going to say NPC fire weapons, dunk, 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 and that's just going to go and fire our primary weapons. Now, I don't think we need any of this stuff at the moment, because if we are too far away, we're already going back to our script. So that's cool. You know, sometimes you need to take a break. That's pretty normal, I think. I need some sleep. I think we're almost done with where we want to be tonight. So right now, again, we are back to the situation where we're gonna gun, you know, fire. But I think that we're gonna want to duplicate a little bit of this logic, because we really only want to fire if we have half a chance of hitting us, right? We don't want to fire like crazy. Now, I do want to have some of the fire logic also in the get behind target, that if we're flying towards someone and we have a chance to shoot, then obviously we should shoot, especially if we're doing chicken run. So anyway, so what we're going to do here is, again, get the target heading. Now, in this case, we don't have to get a whole bunch of other things, so we're just going to do that. Basis. No. Origin. So we need the position. Then we're going to get our npc.get. Okay. Global transform. Origin. Normalized. So that's the vector of us pointing towards where our bad guy is. And I'm actually going to go and copy our NPC facing. We can actually do that the same way. And this is nitpicking, but seeing that we only execute this if we actually have a target. And again, if you don't have a target, we shouldn't even be executing any of this logic. That's just a safety. So in this case, I should be able to just change that in here so that we don't access it twice. In this case, we're going to say var dot is npc facing dot npc target heading. There we go. So we're going to see, you know, what not that dot, what is our cosine for a heading, and in this case we are simply going to say if dots bigger than, and we need a fire angle here. I'm gonna hard code that one for now. Fire angle cos deck to rad. Let's make that 10 degrees for now. I might make that a setting eventually, but the dot needs to be bigger than that for us to fire. And again, you know, we might keep calling this without being able to fire because our guns aren't cooldown. That is perfectly possible. Hi Matteo, nice of you to join. Which hour is it there? It is right now 12:30 in the middle of the night. So you can imagine I am getting a little tired. Alrighty. Let's see if these guys are gonna try and shoot at me now. Let's see if they pick me up first. There we go. They're gonna try and get behind me. So let's see if they actually are already behind me. There you go. They're trying to get there. Now I'm probably going too fast for them right now. Let's see if they can catch up. Or have they lost me already? They're back on their... Are they back on their path? Could be. Maybe I've already... Yeah, I already flew away too far. Okay, that's not good. So, let's try this again. Boom. Let's go for it. So, I was a little too fast in flying away from them, and I got out of range, and they started going back on their patrol. So... Here we go. Getting closer to them. Come on. Alright. Just overshot them. Let's see if they're trying to and get behind me this time. Or did I overshoot them way too much again? I have no idea. Oh no, there they are. Now are they gonna... Oh, yeah, he's starting to shoot. Oh no! He's hitting me too. Oh, he hit his buddy now. Oh, he's trying to shoot me now. Well, he's already got my shield. Pretty sure. Oh, yeah, he hit me again. He's trying hard. Okay, so now he's lost me. I've turned too much, so he's no longer in attack mode. We actually need to have some sort of thing in screen where he can see these decisions. I think I'm going to build something for that. Just like my little FPS thing that we got in there. Got like a little debug thing. He's trying to get behind me. He's having a lot of trouble trying to get there. Oh, he's shooting again. So he managed for a minute. Oh, there he is. Look at that. Oh, he's shooting like crazy, but he's not hitting me. Either that or I'm already on 0 health. That's also possible. I don't think the main player script has the ability to die. Oh, no, it does. I just died. My ship is gone. I'm floating in space. That's brilliant. Oh, I love that. Well, our ship blew up and we were floating in space. Alright, that was quite hilarious. Hey, it works. It actually works. Now, obviously, I'm not really trying to get away from them, but yeah, he was trying to get on my tail, and he was trying to stay there. So yeah, I am actually pretty happy about that. Cool. I think that's where I'm going to leave it off today. We have 2 new states. I think there's a lot of cleanup that needs to be done to make them work better. But we have 2 more states. Our enemy is getting a bit more intelligent. He's trying to first get behind us. And then once he's behind us, he's going to try and follow us and attack us. And if we manage to evade him, he is going to go back to his get behind status and try and get behind us again. So we still need the dodge. But again, I think that I'm going to take the dodge outside of this and make that actually part of the main script. So, or of the main scene. So we're going to, instead of triggering it with our AI, we're going to actually have something in here that's purely looking, you know, am I about to hit something, or am I getting close to hitting something? And if so, I'm going to have an overrule, and I'm going to go force a AI state saying dodge, and all that's going to do is it's going to decide on a random direction, and it's going to make our enemy fly in that direction for a certain amount of distance, and then go back to whatever it was doing before. Which could be, you know, our attack state, which means that our attack state at this point will see I'm no longer behind something because I dodged, I got the hell out of town. It'll go straight back to get behind target, and if I'm still within range of my target, I will start trying to get behind it. But if I got out of range by now, I'm obviously going to go back to my follow path logic, provided that is what I'm doing. You know, the follow path is right now our default, but we might have other default behaviors. So obviously the other thing is we haven't got anything on our wingman. Our wingman is not doing anything about trying to fire at the same target. So one of the things that I'm thinking about is that if our wing leader has found a target, that we find a way for him to communicate that to his wingman, and the wingman will take shots if they can as well. But that's something that we need to figure out. You know, what is going to be the role of the wingman? Is he just going to be there until he gets the ability to to also follow its own target? Or I think that's also going to be a personality trait, right? Depending on, especially once we start getting our friendlies, because the next step here also is to start applying the same logic to our friendlies. So one of the things that I'm thinking about is having one of our friendlies wait outside, and the moment that we exit the carrier, that friendly is going to switch over to being our wingman and start following us. And help us out in some way, shape, or form. And the thing there is going to be character traits, right? Wingman might stay there and protect us, or the wingman might, the moment that they detect an enemy, fly off and attack the enemy, and once he's done, go back to trying to follow us. So there's quite a few things that we can do. The lasers are just standard meshes, and they're actually, believe it or not, they're boxes. Where's my laser beam? Where's my laser beam? Oh, there you go. 3. It's a box. It's just a transparent box. I want to make that something nicer, by the way. This is just a stand-in. I actually want to have some sort of effect on them at some point in time that they actually look a little bit cooler. But yeah, they're just boxes. We're shooting a whole bunch of boxes. So, 7-3. Oh, so Gogart, you just woke up. Very good. Sarah Dev, so you mean the distance? Yeah, so yeah, I wanna improve that logic a lot, that it actually tries to stay at a matching speed as much as it can. Yeah, shaders is a cool thing to do things about. Unfortunately, in the project that we're doing here, I don't think we're gonna have a whole lot of use for shaders. We might do some effects at some point in time to sprout up our the way our lasers and stuff look, but I'm not expecting a whole lot. Obviously, I've done a few things with those Fresnel effects on the UI bits, so that's probably going to be doing, we're going to write some more shaders there, but it's one of those things where I did those tutorials together with Nathan from GGQuest. So I prepared a bunch of things, and he made some of the 2D ones, and I made some of the 3D ones. But it's really finding a topic of, what sort of shader do you want to create? What do you want the shader to do? Because you get into complex math very quickly, and that's really hard to follow in a video tutorial, especially if it's math that you haven't learned in school. All you can do is just accept that that's the math to do a certain thing, and then copy it and use it, and still not really know what it is that you're doing. So to really have a subject where you're really concentrating on what the shader logic itself does, so that you can actually teach someone to use that and turn it into something of their own, is hard. So I'm open for suggestions. I'm always open for suggestions. If there are certain shader techniques that you want to know more about, I can do some research about them, and I can either pick them up in a live stream like this and experiment with them, or do a tutorial about it. So. Yeah, the explosions, you can do a whole bunch of cool things with shaders, especially once you go to class 3 and you start using the particle shaders. You can do some really cool things with those. There are a few that we're going to be building. So one of the ones that I do want to do is the shield, right? So right now the shield is just a fractional effect. But one of the things that I want to do is when you hit the shield with bullets, or you hit the shield with a missile, I actually want that shield to do something. And that's a matter of figuring out the location where we hit the shield, which is a matter of figuring out where our bullet was and what heading, and then doing a intersection test. Because unfortunately we don't get the exact collision spot when bodies hit each other. It's a bit of a shame. Still something I want to investigate if there's not a way that we can make that happen. But once we have the location on the shield that we get hit, we can use that location in the shader to then do a distance calculation from that point to where whatever pixel we are, or whatever fragment we're rendering on the sphere, and do an effect, that then involves time, and you can get a ripple and stuff like that. The other thing that I want to do as part of that, and this is something that Nathan's got a shield effect like that, and I think he got it from Brackeys, Google Brackeys, Brackeys, I think. Let's see if we can find the guy. Hang on for a sec. YouTube Brackeys, I think it's called. Yeah, if you don't know about this guy, is this the guy that I'm thinking about? I think so. Yeah. If you don't know about this guy, go and follow this guy on YouTube. He is I think he does Unity or Unreal. I'm not quite sure. But he has got some really, really cool... Yeah, just Unity. Some really, really cool tutorials on here. And I can't find his shield one at the moment. He has got a really cool shield effect, and I think that's the one that, yeah, this one, force field. And I think that's the one that Nathan has got a version of right now, and that's just a really, really nice effect, and it's incredibly simple. It's a combination of a fractional shader to get that outline shape, checking the depth buffer to get that little effect over here where it's hitting the ball, and then a what's it called, like a hexagon texture to get that hexagon effect on the shield. It's really, really cool. But the fun thing about this, and why I'm also, even though this guy is doing Unity, shaders aren't any different, right? They are GLSL code running on hardware. And okay, you've got DirectX in some of the engines, but even then, the way that shaders work doesn't really change. There might be some syntactical changes and stuff like that. So almost everything that you can pick up in a video about Unity, once you figure out how the shaders in Godot work and how you adapt those things, a lot of that is directly usable. So even someone like Brackeys, who does some really, really nice tutorials for Unity, can still teach you a lot of things about what you want to do in Godot. And the same thing for Unreal as well. There's some really good particle tutorials. I think he's got a really cool particle effect for a gun that I based one of the effects in my weapons tutorial on. I think that was Brackeys as well. I'm not 100% sure. But yeah, the techniques stay the same. It's just adapting them for the tool that you're using. So yeah. All right, let me catch up on chats. Shadow explosions and things. Yeah. So yeah, planet shaders. You can do some really cool things with that. Although I think it's a bit wasteful if you can handle things in textures. But it, again, depends on what you want to do. Hey, Eduardo, thank you. I hope you guys are enjoying this. The engine doesn't have a way to return where stuff collided. No, so you can do it. The engine has got the logic, so bullet itself, but it's not used when you get the signal. So let me have a look at where did we implement that? I think we just did it on the base script, right? No, that's in a projectile script. So when we look at our projectile, we have an on-projectile body entered. So the moment that this guy hits something, we get that signal entered. And all we're getting here at this point in time is the body that we hit. So in this logic, we're not getting any of the extra information that is recorded when a collision happens, and that's a bit of a problem. When you go into the physics engine itself, so through the physics server, and of course I'm looking at the wrong place. There we go. Now here you have all the different functions that are actually being used internally by rigid body and things like that to do things. And I've actually used some of this in the VR in extra tools, like for instance for the teleport. I'm doing all my collision detecting directly on the physics engine, and at that point in time, I need to find out where it is because it's been a while. This is like a collision query that you do. That's set. No, that is get. Yeah, physical body direct state. Yeah, so here when you do when you get a collider, you can actually get all the info. So you can get collider ID, object, position, shape, velocity at position. So there's a whole bunch of things: local, normal, position, shape. There's a whole bunch of information that you get when two bodies collide. So it actually says this here, right? So so inside of its rigid body integration forces, that is what it handles. Now the problem is that the moment that this happens and you've got your collision logic set, so we've got our contact monitoring on, all that does is it sends out that signal with body node, and at that point in time you don't actually have any further information about those collisions. So unless I'm missing something, it's possible that maybe rigid body has a function that we can call to get more info, because we got our contacts reported. Colliding bodies, so returns colliding set to true, contact reported, so that gives us an array. List of collisions updated once per frame with 4 physics now considers using signals down. So so yeah, it's interesting to see that. So I wonder if this is going to give us the information in our signal. It sounds like when we get our signal, that information isn't actually stored yet, which is a problem. So yeah, that is definitely something that I want to look into more at some point in time. So I know that the physics system has the ability to handle this stuff. It's just that some of the physics objects just don't give us the information that we need. So yeah, it's going to be interesting, and I want to learn more about how that works internally and seeing if we can override that at some point in time, or because in the end it's all just calling physics server methods behind the scenes. So there's a good chance that we can actually enhance the logic in our rigid body to get that extra detail that we need. And we'll see. And else there's always workarounds. There's always ways to get around it. Yeah, so indeed. So one of the things that you would do is you get the transform of the projectile, so of our laser at this point in time. And this is also what I did with the... I actually go into quite a lot of detail in... is it part 7 or 8? Probably 7 of the weapons tutorial. The one where I'm starting to shoot with the sniper gun. So there I've got the same problem, right? Where my bullet hits the target, but its position is like the target is here and position is here. So because I've got a really long collision shape. So what I'm doing is I'm taking that and I'm looking at the direction of travel, and I'm basically just casting a ray to the object that I'm hitting. In that case, it's very easy because it is a plane, so it's a flat shape. But in this case, it's a sphere. A sphere and a ray sphere intersection isn't hard either. It's actually a very simple function, and I always forget what it is. I always have to Google it. But that's basically what we end up doing, right? Is finding that vector along which our bullet is traveling, our laser is traveling, and then just seeing where it collides with the sphere. And then we find the point on the sphere that we hit. So we can get there eventually. We'll figure it out. So yeah, it's like a raycast. The thing is, I don't want to use a raycast for it because that's going to do a whole lot more checking than what we strictly need. So, but yeah, that is that might be something for next week. We did a little bit of particle effects when we hit something. Maybe next week we'll start doing some more with the shields and having some fun with the shields. Obviously, we found out that we can die now too, which is an interesting experience. And we're floating in space. So yeah, that's something that I need to figure out and see if I can make nicer, because I just yanked the player the player model out from underneath itself. Yeah, we'll figure something out with that. I'm trying to think about what else we should do tonight before we call. It's almost 1 o'clock. Yeah, never memorize what you can look up. It just fills your brain with crap. So no point. Absolutely no point. Okay. I'm wondering if there's anything more that makes sense to have a quick look at before we call it a night. Let me have a quick look at our shield. Shield mesh. Is that on our... let's go to the wrong one here. That isn't even a something. So you know what I wanted? I wanted to actually make this a little bit less pronounced. I really want the shield to be hard to see by default. We're gonna start doing effects for that eventually. All right. Okay, guys. I think that has been more than enough for tonight. So thank you all for joining in. It was a lot of fun. I think we accomplished quite a lot today. Our enemies are getting really cool, and it's still relatively simple logic. We're not making them do anything really spectacular. They're one of the things that I want to start looking at, and it's something that I might concentrate on in my in between time this week before next stream, is looking at if I can clean up some of that code and put some of the logic more central. There are bits of code that we keep repeating over and over and over again. I'm also thinking about, like I said, applying our state logic to our projectiles. So I'm probably going to add state logic to the projectiles, because that's always going to be an AI thing, right? Where the lasers are just going to be, the AI is fly straight ahead, nothing more. But the missile logic has a lot in common with our NPC logic. So I think that we can have some synergy there, and we can reuse some components there, and it also means that we can control some things a little bit better. So yeah, that's something that I want to do. Is also there. Hopefully we get less duplication of logic. But I think that in due time our AI for our bomber is going to have quite a few more elements in there. So yeah, I'm quite happy about the look of the whole thing. Of course, right now it's just a very simple demo scene that we're using, because that's the other thing that is going to become really important in the not too distant future. Is I need to actually have, because this is not where the game is supposed to start. That's one of the reasons why when we start, we are not looking the right way. We're half the time we're outside of a cockpit, and that is because normally you should already be in the game somewhere where that doesn't matter. So the idea is that when you start up the game, you're actually going to be in a room inside of the spaceship, inside of the carrier. And we're going to be designing that in a way that it doesn't really matter whether you're in the right spots, because you just look around and will probably orient the thing properly. But then when you start the mission, you're already sitting down, you're already looking in the right direction. So the moment that you enter the ship, you're actually looking properly. You're not going to be outside. And then we can add the logic that if you do end up outside the ship, just like we're doing right now, where we're holding our headset up just to look behind us. It's nice that we can still do that right now, because for debugging purposes, that's really handy. But in the real game, obviously you can't stick your head out the window in space. So we're going to do a fade to black or something like that to make sure that we can't suddenly stick our neck out of the window. It is a nice little ship. It's a shame that it's not what I'm after, but it is a real cool model. Yeah, so the asteroids, you can see here, they're all in groups, and yeah, there's a script behind there that updates the multi-mesh and randomly positions them all. So there's a generate asteroids, and all that does is loops through all the asteroids that I want to set, and then within some settings, randomizes position, randomizes orientation, randomizes scale, and then sets them up, and there's our asteroid field. Now, that at this point in time is still a work in progress, because I want to do a lot more with this asteroid field. Right now, it's just so that I have something in space that gives us a feeling of where we are, a feeling of orientation. And it's the same with the planet as well. We're tracking the planet. Right now in the editor, it moves around. You can see that it's not positioned that far off from us, but in game, it's always in the same position relative to the player, and that gives the illusion that it's far away because it doesn't move. And that's one of the things that we do there. So yeah, that's. Those are both things that I want to do a lot more work in, but because I really want to concentrate right now on the flight dynamics, on getting the functionality in our ship all done, so that we actually have all the bases to make a simple mission. Because that's, of course, the next step here is actually creating a situation where we can fly from waypoint to waypoint, do something there, and eventually turn back to our ship and have a proper mission ending. Because that will start allowing us to put additional levels together and have some sort of progression of story and stuff like that. Yeah, I did spend like the first 2 or 3 episodes on getting those asteroids done, and we went through quite a few things. One of the things that's really interesting about the asteroids as well is they actually have collisions. And again, that's another thing that there's a lot more to be optimized there and to be improved there. The thing that I eventually want to do for something like this is generate everything from a curve. So you basically build a curve that is a section of an asteroid belt, and then we start creating multi-meshes around that curve with high volume of asteroids in the middle and lower volume in the back, and then we start adding some LODs so that if we're too far away, we're actually not rendering actual asteroids, we're just rendering bitmaps, or maybe even just pixels, because when they're like this far away, it's just a pixel, right? So you can create the illusion of having far more objects on screen than are really being rendered in full detail. So that's something that I do plan to do in the future, but I want to do that once we're a little further along, because you can easily spend another 10 streams perfecting an asteroid field. That gets very tiresome to watch at some point in time. It's much more fun to actually build actual game mechanics. So that's what we're going to be doing for the foreseeable future. As far as Glass 2 is concerned, and I've said this before, the Glass 3 renderer, and especially what John is doing right now with the Vulkan renderer is just amazing. He just posted screenshots about the fog that he's working on, and sort of going like, the fact that he is doing this now full time, fully funded, is allowing him to make such progression. It's amazing. Now, I could use fog in this. I do have to admit that. I think it would be really cool that if you look at a scene like this, that you would actually have sun rays going through the asteroids. That would be a nice little gimmick. But when you look at these type of games, space is empty. Even when you have a lot of asteroids in space, it's a lot of empty space. There's one light source, the sun. Yes, you get some small lights on ships, but they don't shine very far. So all the funky, really cool lighting effects that you need in a game, like if you do an open world game or you do an outdoor game or whatever, you don't need those in space. So I don't need all that power and functionality that's in the Glass 3 and the Vulkan renderer. And the bonus that I get by going back to the Glass 2 renderer, which does nothing more than that I needed to do, is performance, because it doesn't need to do all the extra work to do all the extra lighting stuff that I'm not using anyway. And the Glass 3 render or the Glass 2 renderer is a really well written renderer. It implements most of the PBR spec, even though it's not HDR and it's not it doesn't do color grading and all that sort of stuff, or color balancing, I should say. It's all still standard 8-bit per color channel calculations. So, but yeah, it's for what we want to do in space, it is more than capable. And again, one of the reasons I wanted to stick with Glass 2 is to try and minimize the amount of performance this thing takes, so that we could run it potentially on lower end machines in VR. So, and I still have a long way to go there, right? I have not been doing any optimization right now. This is a very beefy machine that we're running on. It is a laptop, but it's still a very fast laptop. I know that, for instance, the carrier is a model that is made in such a way that doesn't actually rhyme with optimizing stuff. That's not a fault of the person who made the model, by the way. It's just the way that it's been exported and the way that I'm using it. If I had access to the original, I'm pretty sure that you can export it in a way that that would be much more useful for what we're doing here. But again, like I said before in earlier episodes, it's a standard model. We're not going to keep it. So once we have more working and we're starting to look at actually designing models specifically for this game, then we are going to start looking at, okay, where are the performance bottlenecks? That's not something I'm too concerned about right now. All right. Just to make Grogard happy, because he missed all the beginning videos. Ah, dang it. I really need to do something about that. Okay, let's see. Gentle, gentle, gentle. Let's go outside. There we go. Ah, still hit the bloody ship. Yeah, I definitely need to make sure that the shield is not on when I'm inside the carrier. Let's go flying, 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 flying. Da, da, da. Boom. Oops. Yeah, I'm not being really pushed away or anything. I just kind of get stuck against this thing because I'm just full thrusters going into an asteroid. Wow. And that's because my shield is a sphere. One sphere rolling against another sphere, I get rolling. So yeah, we definitely have collision shapes on the asteroids. They're not all on. That's the trick. That's the way to get performance for that. Yeah, I don't know. I think when you look at building your game, I don't really see the point of waiting on Godot 4. Now, obviously, that might mean that you hold back on some of the effects that you want to do, because those are definitely going to change. Like, for instance, Jean says that he's going to work on a new particle system. So that's something. Obviously, there's VR, a lot of things that we still need to do. So there are going to be changes if you are building your game for Godot 3 and then decide at some point to port it to Godot 4. A lot of it will work. A lot of it you will need to change. That's just the way that it is when the complete renderer is being rebuilt. But I think it's not a good reason to hold yourself back. Because there's so much that you can already build that is not going to be any different. When you look at your locomotion mechanics, when you look at your interaction, the fact that you're shooting at bad guys, or your your whole physics engine experience is gonna all the work that you're gonna do in Godot 3 will be usable when you then decide to move your game over to Godot 4. For me, I am, I'm probably, with this project, the way that I look at it right now, I'm going to finish this in Godot 3. And that's purely because of the low-end target that I have. And the fact that I am focusing on the Glass 2 driver at this point in time. I may change my mind on that. It has a lot to do with how good the Vulkan renderer will be for lower-end applications. And, the fact that, and that's kind of what the Glass 3 driver suffered to some extent as well. Although I've got the feeling that the Vulkan driver is way ahead of the Glass 3 driver, is because the benchmark has been set so high. One of the problems that Godot has had over the years is everybody's saying, like, okay, it can't do the graphical things on the high-end side that some of the other engines can do. Well, the moment that you start supporting those things, you get into a position where you therefore also need modern hardware to run it. And when you look at VR, even with modern hardware for VR, because you are rendering stereoscopic on high resolutions at much higher frame rates than games do, that there's a payoff there. If you go for that next gen ultra realistic look, that costs performance, and that means that if you're not targeting that, all of a sudden you're putting yourself into a difficult position when the engine is built for that that next generation sort of thing. Now that said, obviously all the stuff that's being worked on right now is all that high-end stuff, but the architecture of the new renderer is such that it has the promise of better being able to deal with the lower end stuff as well, and basically disabling stuff or not using parts, and still being able to run on lower end hardware simply by disabling stuff or using a low fidelity version of the renderer. So we'll see. Yeah, 4K at 90 FPS. It's pretty damn crazy. Mind you, when you look at the fact that people who have really, really beefy machines are starting to run their games on 144 hertz on 4K TVs, you know, the hardware is getting there. So, well, I think for your game, because it is, you know, because you're in like forest scenarios and stuff like that, I think there are definitely merits for the Glass 3 driver, or at least possibly developing on the Glass 2 to limit your performance and then or performance issues. But then once Godot 4 is out, starting to really amp up the visual part of it with the Vulkan renderer. I think it's for you. It's a more difficult choice than for me because like I said, I'm in space. I have one big light source. I don't need all the cool stuff. But I think you're in a position where unless you go down the same route, because this is of course the thing that the Quest has really taught us. When you look at the Quest, when you look at the fact that that thing can't do, you're working on very constrained mobile hardware. It's really amazing how much Oculus is able to pull out of that thing. But in the end, you look at one of my favorite games on it is Robo Recall. And I played the original Robo Recall on my Rift CV1 when it came out, and I loved it. My kids love it. They've all played through the whole campaigns. And of course, on desktop, it is Oculus pulled out all the stops to make that a showcase game for their platform. It looks smashingly good. And then, of course, they made it for the Quest, and they toned that all down. There is very little lighting. It's all baked lighting into textures and all that sort of stuff. It's all fake shadows. There's not real shadows. They're rendering little blobs on the floor to pretend being shadows, if I'm not mistaken. Could be wrong about that, but that's what it looks like to me. So the graphical fidelity of that game on the Quest has been toned down so much, but you don't care when you play it. That's the amazing thing about it. The Robo Recall on the Quest is just as much fun to play as it is on the Rift S, and you'll notice on one side you notice how much they still got away with and making it look good. But at the same time, if you start paying attention, you're really going like, this is mid-2000s polycount type of game. It's the car wrecks on the street are low poly. the buildings are boxes with really cool textures. But it works as a result. And the experience, that's really what matters. So yeah. Yeah, I've got this is an Alienware laptop with a 2070 in there as well, and I have to say it's an impressive piece of hardware. But it's I think the big problem that you have, and I've seen this a lot, and that's I think where the difference lies with who builds games, and especially in indie. I think one of the Achilles heels of using an engine like Unity or Unreal, and to some extent even Godot, is that these engines allow people to build games without a deep understanding of what is happening in the background. And those who use that well make really, really good games. But there are also a lot of people who sort of want to throw everything to an engine and just have the engine solve their problems. So one of my favorite examples coming from a situation here in education, one of the games educations here, was an example where someone was doing a school project, and the artists provided all the. I think they were making like a horror game or something, like an indoor horror game, and well, they put a bathtub in the game, and all of a sudden the game didn't perform anymore. And it turns out the bathtub had 50 million polygons or something like that. Yeah, it's a bathtub. Like, what the hell? And that's the sort of example where everybody who's been in the game business goes immediately like, that's stupid. Who makes a beginner mistake like that? But once you start digging deeper in some games, you start seeing more and more that a lot of people don't know what costs performance. And sometimes they do something really simple that they don't think about, which is really hard for a computer to do. And that's the one little thing that's making their game run like crap. But they don't know it because they don't realize that is something that is costing a lot of, and this is not even indies, right? Indies obviously is easy to point at, or even people who are fresh out of school and doing their first game. They make all the beginners mistakes, and that's part of your learning experience. That's normal. But even on high end, one of my friends in Holland, he actually made a business out of it. He just goes into companies that make games and have performance issues, and he works on their games and optimizes those things. And that's purely a matter of knowing knowing what things work fast and what things don't, and finding alternative ways to make something work without the person who's playing the game noticing that something has changed. Other than that, it's suddenly performance. So fun stuff. Well, yeah, collision collision shapes are really, really interesting, and that's something that I have a lot of work to do in here as well, especially because we've now upped the physics process rate. So what you'll see here, for instance, is this bomber has got a sphere shape. Sphere shapes are the most efficient collision shapes there are. If you can use a sphere, use a sphere. Absolutely. Box is the number 2. So what you can see in here is I've got a big box there, and I've got a box there, and a box there, and a box there. So there's 5 boxes. That's it. But because I'm using box shapes, I'm not using a mesh converted to a collision shape. I'm using the box collision shape. What a lot of people don't realize is that that's not a polygonal object. The physics engine does not work with polygons. It works with volumes. It works with mathematical equations that represent a volume, and mathematical equations that figure out whether 2 volumes are overlapping. And it can do that really efficiently with these primitive shapes. But then for fun, I try to use a simplified mesh shape of this fighter. And I think it was even the one that comes in if you do the convex sibling. And that just killed my performance completely. And a lot of that has to do with the fact that I have all these asteroids in the background. But even then, the amount of processing that you need to do on complex physics shapes is it can be very detrimental to the performance of your game. While if you stick with the primitives, at any given time we're checking 10,000, 20,000 collision shapes right now with the asteroid belt, so it can definitely handle it. And again, that there's a lot of optimization even here that I can do. And it's something that we even know, especially when I'm starting to fire the guns. Every laser bolt is a collision shape, and it's a rigid body. So, if you have and that's I think why we had a little bit of performance issues earlier on when the enemy ship was going absolutely crazy shooting at us. But there's definitely some improvement that we need to do there, and some stuff that we need to do with it. Because we're doing so many collision checks every frame, it's something that you can easily overload what you're doing if you're not careful. But you need to know what you're doing. That's the thing. Yeah, and the thing to keep in mind of, you can have the best graphic card in the world, it's not going to help you physics. And yeah, I know that there are GPU accelerated physics engines out there. They have their own set of problems. What a lot of people don't realize is when you're looking at physics simulation for the purpose of visualizing what's happening, like for programs that do like water simulations and that sort of stuff, more the scientific type of programs, that's the ability to do that many physics shapes on a GPU like crazy, great. But when you have a game, you have a fundamental problem, and that is timing. First of all, you're already keeping your GPU busy rendering, so you're dealing with, hey, you need to reserve some of that power for your physics engine, but you also get everything running on a completely set of parallel hardware. So our game logic and our physics logic might not be in sync, so we might actually not detect things in time because our physics simulation is is a frame or two behind, or is maybe a frame or two in front, depending a little bit of what it's doing. So yeah, there are some issues there to solve, some very unique issues that you don't have when you're running stuff on the CPU side. Although you will still run into similar problems if you start doing physics in multi-threading. So there's that. I don't have the answers there. I don't. We'll see where it all goes. Hello, Nora. Welcome for joining. Although we are at the end of the stream because it is 1 a.m. here. 1:30 a.m. I am way past the end of my stream. Oh boy. All right, Island Yan, about FPS and delta time. So, there is a difference between physics and rendering here. The physics engine is designed to run at a fixed rate. And I wouldn't say frame rate, but a fixed number of updates per second. And that is because only if your step size is constant do you get a predictable physics simulation. The moment that you're going to, and this has got everything to do with acceleration and stuff, being logarithmic and or exponential. So if you start varying that, you start getting a variation in outcome, which can give some really funky results. So the physics engine, you set to a fixed update rate. So in my case, it's set to 90 frames per second, or 90 updates per second, I should say. So our delta is fixed in our physics process. But that means that, for instance, if my rendering can't keep up and I'm rendering at, say, 80 frames per second, then some frames I'm actually doing 2 physics steps. And that could, on 90 frames per second, it's not noticeable. But let's say that you were running your game on 30 frames per second. That's what sort of creates stuttering in your physics simulation. Because every other frame you're suddenly doing 2 steps and it doesn't sync up. Now, when you look at rendering, the number of times process is run is equal to the number of frames that you're rendering, because you're running process to decide your last bit of game logic, and then you render a frame, and then you do the process for the next frame, which actually happens in parallel with rendering. The rendering actually always runs about 2 or 3 frames behind, which is something that people don't realize. But what you're seeing you know, your game logic is already a couple of frames in front of what you're actually seeing on screen. You know, that's just got to do with the parallel processing of your GPU. So in a very simple way of saying, I'm rendering this frame, and at the same time I'm already running the process for the next frame. And then when that's finished, you wait until your frame is finished rendering, and then you start rendering the next frame. So the result is that if your frame rate goes down, it takes longer between one process call and the next process call. And the delta in the process call will tell you exactly how much time has passed. So the slower your FPS, the less frames per second you're rendering, the higher the delta value in your process, because more time has passed between the previous frame. And you use that when you want to have things move at a seemingly constant pace. So I am not on Instagram, Eduardo, if you were asking me. Not much from a photograph guy, unfortunately. So when we're looking at physics, you have something called broad phase and then narrow phase. So the idea being that you first do collisions purely based on the possibility of two things colliding. So when we are looking here, and we look a bit up, so here we've got all our asteroids, right? So instead of checking each and every one of these asteroids whether it is colliding with my carrier, which is impossible, a lot of these are going to be grouped together in what's called a BSP tree. And the broad phase collision detection simply is going to go through this and discard a whole bunch of, or not even check a whole bunch of collisions because they are not possible, because that object is nowhere near any of these. So it's going to do this with purely with bounding boxes, very quick, figuring out possible collisions, and after that it does a narrow phase where it actually does precise collision checking between the pairs that are left. Then you have a pair, list of objects that are actually colliding, and the physics engine then reacts what it is doing there. And again, that's also where there's different ways of handling whether because also, when my ship moves from here to here, there's actually, I've checked the collisions here last frame. Now I'm going to check the collisions here. If there was something in between, I'm not detecting those collisions because I've sort of teleported over it. So there's a whole bunch of strategies for that that are also going to come into play and stuff like that. So, but yeah, physics engines do it in two steps. They do a broad stroke where it tries to figure out what could potentially be colliding based on their bounding boxes, and there's a hierarchy there, a BSP hierarchy, so that it can, instead of checking the bounding box of every single asteroid in this case, it is going to first check a bounding box that groups a whole bunch of them together. Well, if that big volume isn't colliding with my carrier, none of the things inside are going to be colliding with my carrier, that sort of thing. And then it's going to do a more precise phase with just the things that it's identified that potentially could be colliding. Yeah, multi-threading is it gives a whole bunch of new issues, and the only scenario where it really does pay off, I guess, is when you do have a machine with multiple cores that could run a whole bunch of things in parallel. That's where it works. But in the end, for your physics to really work, you need it synced with your main stuff, with your process logic. That's a big problem. If it's completely independent, you get this really weird disjoint. Then there are some problems just with parallel physics and or threaded physics and VR, which I haven't figured out. for some reason, it's possible for the physics engine to update positions of objects between rendering the left eye and the right eye, which is not good, I can tell you that much. I haven't figured out why it does that yet. But I have a feeling it has to do with the way that it builds the position lists, and the fact that the physics engine can update the data that pointers are pointing at. So I don't know, it's annoying. So I try not to do it, and I try to figure out, okay, how can I stay within the budget that I have? This is the other thing that people often don't forget. It's the same story that I talked about last week or the week before. When you look at the speed of GGScript and the performance of GGScript, it only matters if what you're doing in GGScript, which should be control logic, which shouldn't be logic that is very performance sensitive to begin with. It only starts mattering when the amount of time spent processing stuff in GGScript starts to approach that 1 frame rendering time. Because what you actually find for most applications is that your CPU is waiting half the time. Because it's your GPU that's doing all the work. Your GPU is going to be your most likely bottleneck for rendering speed. And again, physics is probably the only exception to that. And physics isn't even running in GGScript, right? It's a complete separate thing. Because when you look at the time that it takes to render 1 frame, that is when you're doing the process for your next frame. So if that takes 1/90 of a second, and you can do all your process in half that time, the other half of the time your CPU is just waiting for the previous frame's rendering to finish before it can start rendering the next frame and processing the frame after that. So there's no point in optimizing your code if your code is going to execute much faster than rendering 1 frame to screen. And that's where your bottleneck starts. Yeah, and that's where profiling becomes important. We're finding out which one of those two is actually, costing more than at 1/90th of a second to do. If it's the rendering engine, you know that you've got too many things on the screen, or your shaders are too complex. If it's the CPU, then you know that you're doing too much on the script side, or in physics. And that's the first thing that you need to find out. Which one of those two is your bottleneck? And then find your solution accordingly. And I bet that unless you're doing something stupid, like, updating terrain in GGScript, that's probably not something that you want to do in GGScript. But unless you're doing something like that, I would bet that GGScript is not your bottleneck. And another thing that GGScript can't do is, looking at the situation here where I've got, tens of thousands of asteroids, I can't go and update every individual asteroids every frame in GGScript. That would kill performance as well. That would definitely become a bottleneck, which is why we do it in shaders, because shaders, they got plenty of processing power. Yeah, the Darts mini game was a lot of fun to write. I learned a lot doing that tutorial. That was really cool. Knowing all the principles behind how physics are supposed to work is a very different thing from actually trying it out in practice. And even that, I went a step farther with the weapons tutorial, and even here, there's things in here that take those principles a step further as well. And there's a lot of things that we still need to improve. Asteroids being a really good one. Okay, everybody, it is 1:45. We have been streaming for how long? I don't know. Long. We started at 9, so 10, 11, 12. What? We're almost up at 4 hours. 4.5 hours, I think. So yeah, that was a bit longer than I intended. But a good night. I think we've done a lot. We've got everything working. We've got our enemy bombers following us around and trying to shoot at us, which is which is great. So I will be polishing up the AI a little bit more over the week if I find the time for it. And then I think next stream we're going to do a little bit of fun with the shields, getting some effects done in the shields. I think that's actually we've been working on AI for two streams now, so I think we need to shake it up a little bit. We're definitely going to return to the AI because there's a lot more AI that we need to build in here. This is still very simplistic. But I think next week we're going to have a look at the shields, make the shields act nice, make the shields regenerate when you take them down. Might start looking at some energy distribution sort of logic. So that's I think a good topic for next week. So yeah, I hope you guys all enjoyed it. I hope you learned some of it, or something from it, and I hope to see you guys next week. So yeah, have a great night or a great day if it's morning for you, depending on where in the world you are, or afternoon. And yeah, thank you for watching, and I will see you next time.